Hey everyone, I'm Uttam Singh and I'm back with another crash course. And this time the topic is MEV. This is one of the topic that always fascinates me and also one of the most important topics if you are in the blockchain ecosystem and in the DeFi ecosystem, right? So everyone should be aware of MEV if you are in this ecosystem and if you are into DeFi and Web3, right? And yeah, let's get started with this video. Thank you so much for the support that you guys provided in the last video. The count abstraction one was a massive hit. So if you haven't watched that, go and watch that and also watch other crash courses like EVM, stablecoins, and the flash loans ones as well. So without wasting our time, let's get started with this crash course as well. Cool. So what is the agenda for this crash course? So this crash course is on MEV, Maximal Extractable Value or Minor Extractable Value. In this particular crash course, we will call it as Maximal Extractable Value. We will discuss it why it was called minimum and why now max. So the first topic will be, as usual, the history of MEV. We will go through what's the history, what's the background, what always happened with MEV, how does it actually exist, right? And after that, we will also go through prerequisites of blockchain, like to understand the MEV ecosystem. How does MEV works? A person needs to know how the basics of blockchain basically, right? So we will go through the basics of blockchain. If you are already a blockchain expert, if you already know how blockchain works, then you can skip this part. The third one is, what is MEV? What is MEV? Actually, we will go through that. How does it actually work? We will go through the diagrams. We will look into all the components. And after that, we will go through MEV examples. What are the examples of MEV? Like, what are the things that, what are the things that MEV is generating? Like, and how is it generating, right? There are different types of MEV, examples, arbitrage, and the sandwich attacks, front running. So we will go through each and every type with example, and I will tell you everything about it. After that, we will go through MEV solutions. So what are the solutions of this space? Like, is that even possible to create a MEV resistant blockchain? Or if not, then what are the solutions? How is the industry coping up with it, right? So we will go through Flashbots. So Flashbot is like one of the major organization in this MEV space that is working on, right? So we will go through what Flashbots is doing, what are the new solutions in the space. MEV Boost, PBS, PBS is proposer builder separation, right? It is a proposal, so we will talk about it, right? And this is like as of now, it's the hype right now, the PBS one, and we will also talk about some opportunities, like since my goal is to provide you guys with more and more knowledge and opportunities, or how you can grow in this blockchain ecosystem, how you can contribute, how you can get a job or everything, right? So I will tell you all the opportunities that are there in this particular MEV space, and you can pursue career in this space as well. And then after that, as usual, I have separated the coding part with the theory part, because a lot of people who watch this crash course are not always developers, right? And they're like that, we don't want to go through code base, we just want the theory part. So I'm keeping the theory part separate, and once the theory part will be finished, we will go through the live MEV, right? We will go through the coding, and we will also code like MEV bot. And I will also, show you in real life how, I will get myself front run. What is front run? We will show you. And we will also create a MEV bot, and we will also go through some code bases. So without wasting our time, let's get started with our video. Cool. So the history of MEV. So the first ever recorded case of MEV emerged in 2014 on the Ethereum blockchain. It discovered by an analyst coder. He was extremely interested and hopeful in the technology until he realized a fatal law in the system. After that, nothing happened till 2019. Okay, and then in 2019, a group of researchers from Chainlink Lab published a paper called Flashbots 2.0 that highlighted that MEV isn't just a theoretical practice. It's just not a theoretical practice. Rather, it is already a functionality that was being directly exploited. and which can have significant impact on the user experience. So the paper you're seeing on the screen is that paper that was given by Flashbots 2.0, like these Flashbots organization. They were like bunch of Chainlink Labs researchers, right? They got separated, and then they proposed this paper, Flashbots 2.0, front-running transaction reordering. You can even see the date. It was submitted on 10th of April 2019, right? So yeah, this was the paper that was released, and after this, the history of the MEV thing actually started, and people were getting more and more aware about MEV, and people realized that this is one of the things that is hindering the user experience of the Web3 users, right? So, and people started giving importance to it, and then we have multiple solutions. Flashbots came with few of these solutions, and how actually we can use improve the user experience, and how we can come up with more and more solutions to help validators to get maximum MEV, right? So this is simply the history of MEV, nothing special. But if you're interested, actually you can go and read this paper. I will provide the link in the description of this video, so you can just directly go and read this paper, which you might learn a lot of things if you're not even aware of MEV. Okay, now let's get started with basics of blockchain. And one more thing before starting, this is all post-merge. So whatever we are going to talk about in this video, this will be all post-merge. So merge has already happened. That is, the Ethereum has moved from proof of work blockchain to proof of a stake chain. Okay. So this of everything we will be talking about, this will be all post-merge. These basics are like simple, for both, but we will talk about post-merge, that is POS. Okay. So what now happens actually? So if you are a user, okay, right? So you did a transaction. Suppose, for example, you are a user, you want to, swap your funds with ETH and USD, whatever, right? You goes to the Uniswap front end, right? And after that, you connect your wallet, you provide the permission, right? And after that, what it actually does, it creates call data. Okay, it creates call data whenever you want to swap or something. First, you have to already you need to authorize your transaction with the wallet, and after that there will be an RPC. So if you're not even aware of that, like your MetaMask has this RPC, right? That it uses to connect with the blockchain, right? So whenever the communication between the blockchain and the the nodes, blockchain and the application, basically your MetaMask wallet, that is happening through that RPC, right? So with that RPC, this transaction will be sent to these nodes, right? So there is a user, right? You went to Uniswap, it creates you did your swap or something, right? And then it creates call data, and then that your transaction goes to the nodes, okay? And after that, your node your node submits your transaction to the blockchain, right? No, it is not that much simple. Now what? Suppose there is just a single node, or there are even multiple nodes. But what if your transaction goes to this nodes, and this node goes down, right? This nodes go down, and after that you will have to wait for this node to come back online, right? To submit your transactions. And this way, it is not a very good thing, right? If this node goes down and your transaction is with this node, then your transaction will be stuck, and your transaction will not go to the blockchain, right? So that's why this is not the case. Now what is actually how does it actually work? So we have a user as usual, and you did the transaction, right? And you did the transaction, and it goes to the node, right? Now, what is actually going to happen, right? The receiving node, the node that is going to receive the transaction, it's going to check to confirm that the transaction is valid or not, okay? And after certifying the validity, it adds the transaction to its collection of pending transactions, the so-called mempool, okay? So there is a thing called mempool, okay? So what simply mempool is? So mempool is basically a list of pending transactions waiting for validation from a node before it is committed to the block on the blockchain. Okay. And after inclusion into the mempool, the transaction stay in a pending state. Okay. Until they are selected to be a part of the next block to be, added to the blockchain, right, by the validator. Okay. So your transaction goes to this mempool. Okay. And after this mempool, any node, any validator, they are gonna basically pick up the transaction, and after picking up the transaction, it is gonna go into a block, and then it will be, that blockchain, that particular block will be submitted to the blockchain, right? So this is the case. There's no, only one node that it's not the case that your transaction goes to only one node and then it directly goes to the blockchain. It goes to a mempool, which is like a public list of pending transaction, and it's waiting for validation from a node. So basically it's, after that it goes to the mempool, it is picked up by the validator, and then it goes into the block, and then that block got submitted to the blockchain. Okay. And one interesting thing to note down actually is that there is not multiple mempool, like there is not single mempool basically, right? This is not like a only mempool that is available. There are multiple mempools, like there's no single public mempool available. They were like public, different mempool that are available to whoever who is running the node. So let us see in the future example what I'm talking about. Okay. So what is MEV? Like now you understand that this is the way, this is how the basics of blockchain is. What is the journey of your transaction, right? It goes to the mempool, and then after mempool it goes to the block, and then that block is added to the blockchain. Okay. Now what is MEV? So MEV is a maximal extractable value, also known as minor extractable value. Minor, why we used to call it minor? Because when the Ethereum was proof of work, then there were miners, right? So that used to mine the block. And now in proof of stake it is validator. So we are basically now people call it like block builders, right? So better to call block builders, and that's why the term has been changed from minor extractable value to maximal extractable value, and we will call maximal extractable value in this whole crash course. Okay. So it refers to the maximum amount of value that a blockchain miner or validator, basically block proposer, can make by including, excluding, or changing the order of transaction during the blockchain process, right? So as we have discussed the basics, right? So what is happening right now is that your transaction, like all the transaction, not just your transaction, like there are separate users, like different users, right? Multiple users, right? Thousands of them. So every transaction is in this mempool. Okay. And and who adds these transactions to the block? That will be the block builder, or maybe the validator, or the miner, right, in proof of work chain. So they have this ability to pick up the transaction. It's not like that if your transaction, you have signed the transaction first and it goes to the mempool. It is not the case that your transaction will be picked up first, right? Anybody's transaction can go to the, it can be picked up first. It also definitely depends upon how much gas fees you are providing, right? So it is not the case that you're just the highest gas fees, right? So there are multiple transactions in this mempool. So the validator, the block builder, basically the miner, right? They have the ability to reconstruct, like to not the reconstruct, but to change the order of your transactions, right? And by changing the order of this transaction, right, they exploit this power, right? So simply putting, block producers, the validators, can determine the order in which the transaction are processed on the blockchain and exploit that power to their advantage. And how do they exploit their their power? Is that, like, for example, they can have multiple strategies. We will gonna talk about all these strategies, right? So they can have like multiple strategies. So in simple terms, like if you are someone who wants to buy something, so these people can see it in the mempool, and they can actually buy it before you, right? They can actually submit a transaction before your transaction, and they can buy it, right? If you're confused right now, it's okay. We will when we will talk about examples, you will get it, right? So in simple terms, like just now remember that MEV is just basically that these validators, these block builders, have this power to reorder the transaction and censor transactions within the block they produce, and with this they create a value, and that value or that money created is known as maximal extractable value. Okay, cool. Now let's move forward to our another slide, like again the blockchain basics. Again, basically talking about continuing our previous example, right? So on Ethereum, the default way a block proposer sequence transactions in their block is by gas auction, right? Including the highest paying transaction in decreasing order. So whoever pays the transaction, more gas fees, it is in the decreasing order. When sending a transaction, a user needs to pay a gas fees based on the computational complexity of the transaction. So, it depends upon what kind of transaction you're doing. You're swapping, you're deploying a smart contract. So based on that complexity, there will be, your user needs to provide a gas fee based on the complexity of the transaction. The current per unit cost of gas, right? In addition to this, they can include a priority fee tip to incentivize a validator to include the transaction ahead of the pending transaction. So if you are, if you're submitting a transaction, there is a thing called priority fee. You can, give basically a tip to the validator to include your transaction ahead of the pending transactions that are in that mempool, right? There are multiple pending transactions, right? So you can give a user basically, he can give a priority fee so that his transaction is, carried forward first as compared to other transactions in that pending mempool, right? And then the mempool. So although, there are measures to place to prove that all the transactions are valid and not double counted, but there is no way to actually ensure that they will be arranged in the same order that they are posted on chain. So it's like that if you posted your, transaction on 10:01 and, basically anytime, let's not take time, but if you posted a transaction at any time, it's, if there is a user that posted the transaction, after you, maybe his transaction can, get confirmed first than yours, right? So this is the case. There's no way to actually ensure that there is a proper order in the transaction that they are posted on the chain, right? So this is why, like, the block producers select the transaction from the mempool, which is like the blockchain queue for, we have talked about the mempool, right? And they are able to prioritize transaction with the highest fees before the submission, right? So again, continuing with our examples, there is a transaction mempool, right? So what can also happen is that there are a lot of, bots that are already deployed on the blockchain, okay? Not basically deployed, but, a few of the smart contracts that can see it, or, there are like MEV bots. We will also create one bot, so don't worry, right? So there is basically a program that is there, and it always, sees the transaction. So this, as I said, that this is a mempool, right? This is a public mempool. There's no single mempool, like anybody can run a node and they can see it. And now these days there are like APIs available that can help you to see these mempools live, right? So these MEV bots, they, continuously are looking into this mempool, like, hey, what are the pending transactions? They're always looking there, right? And whenever they see any opportunity, they will just copy your transaction before you and provide more gas fees, and then, they will basically provide your transaction to the blockchain before you. So if you are, you suppose you won a lottery or something, you did something, basically you found out an answer, right? You posted the transaction, and then these MEV bot can see that answer, and then they can basically simply, go ahead of you and submit that answer, right? It's not a good example, but yeah, to understand that, suppose there is an answer in the mempool, since this mempool is public, right? So they can see your answer and they can actually submit your answer before do it. So they can get the first string and you get the second one. Okay. So this is like the simple example of how these, MEV bots work. And this is only called a maximal extractable value, right? So they are actually, gaining a value by creating this, right? So if you are going to get something, a prize or something, right? So they will get that prize. And there are different strategies, right? We will talk about in like the next slide. So in simple way, they are creating value, and this is known as maximal extractable value. Okay. Moving forward, so what is the MEV flow? Okay. So we will go through each and every separate topics in deep, like what is searcher, what is builder, what is relayer. Just don't get confused as of now. I'm already telling you. We will go through each and every particular component. Okay. So MEV, there are multiple actor involved. There is no single actor involved. There are like multiple actor involved. So it's due to the resources and expertise required to extract the MEV. Right, it is common for block producers. Like block producers means the validators, basically the block builders, right? Also called miners or validators. So this is a confusing terms, no? Block builder, block proposer. So don't get confused. Okay, just follow this image, and we will talk about it. So due to the resources and expertise required to extract MEV, it is very common for block producers like the block validators to outsource the creation of the block to a third party. Okay. So rather than creating the block themselves, right? So there is like, as we see in this diagram as well, right? So rather than creating this, so rather than suppose this is the validator, this node has been chosen to be the validator. So they will have to create a block, right? So rather than creating this block by themselves, what they will do is, this is the block. So this is a node, right? Just compare this to this. Okay. So this person, this validator, rather than creating this own node itself, what he will do is basically he will, outsource his work to different people here, right? Different components, different partners. And what they will do is they will help him to get the more and more value out of that, that particular block. Basically, the more value of MEV, right? So searchers, for example, these are searchers. They seek out the MEV opportunity and create bundle of multiple transactions. So again, moving from this beginning, like there is users, all your transactions, like the different users, right? Your transaction goes to this memory pool, like the mempool, basically, right? Everything is public, right? And these searchers, basically, they seek out to MEV opportunities, like how they can actually, create MEV opportunities out of this mempool. And, they create a bundle of transactions, and often containing like another user transaction, right? These are like transactions that they create in a particular manner, like this will go first, and then this will go first, and then this will go first, right? So they often, they create a bundle, and then this bundle is sent to the builder, right? Who combines the bundles into a block, right? Block payload. They, they create a block, right? And then these builders then make available full block to the relayers. Okay. These relayers are, there, and which serves as the connection point to a blockchain block producer. Like, and I will explain every single detail to you, like after we move forward, after we discuss the type of MEV, right? So don't get confused here, okay? So we will go through each and every, even after this crash course, even if you want to become a searcher or builder or whatsoever, if you want to, deep dive into any component, you will be able to do it. I will go super deep into this, and we will actually talk about the code base. We will talk about every single detail of it. Trust me. Okay. And then after that, the block producer, it submits the block. Okay. So there are multiple actors involved in this MEV flow. So just wanted to clear that to you guys. Okay. Now let's move forward to types of MEV attack that are possible right now. After that, we will go through the different components that are available. Okay. So what types of MEV attacks? Okay. So what are the attacks available? I hope you guys now understood what MEV actually is. This meme is like one of the good memes. Like suppose, for example, there's a trader or basically a user, right? He's like, hey, I made this profitable trade. He submits this to the blockchain, and there is like MEV bot already sitting there. He's like, hey, you made this? He asks this, and he says yes. And after that, he gives it to the bot, or basically to the mempool, that hey, please submit this transaction to the blockchain and I will be rich. But after that, he's like, oh, I saw this transaction, so I can take this profit, I can be rich first. So he's like, yo, I made this So it's a good meme, like, traders, most of the time, even, there are some security researchers. So there is a good blog that is by a Sam Z or something, right? He's like famous influencer on Twitter. That is, Ethereum is a dark forest. So I will suggest everyone who is watching this, go and read Ethereum is a dark forest. It's a very very great blog post that you should check out. Okay, and yeah, so I hope you understand now MEV. So now let's talk about different MEV attacks. Basically, MEV attacks are strategies used by these miners, like validators, like these people, to exploit their ability to reorder, include and exclude transaction, right? They can include any transaction, they can reorder your transaction, and within that they maximize their profits, as previously mentioned. And these are some common types of MEV attacks. One is front running, back running, sandwich attacks, arbitrage, time bandit attacks, right? So they're like multiple of them, but I'm just mentioning the 5 of them, basically the most famous ones, right? So let's move forward, and I hope you will better understand now what MEV is. So let's talk about front running. Okay, so this is like a very single example. So this always happens when a participant observes a profitable transaction waiting in the mempool and quickly creates a similar transaction within the higher guesser prices. Okay, so what is gonna happen is there are two characters, Alice and Bob. These are like famous characters. Alice and Bob always used in blockchain and basically cryptography actually. So Alice submits correct answers with less gas fees, okay, like 15 GUI, right? But she is very smart. She, submits the answers first, right? And what happens is that she is trying to submit that answer to the blockchain, on chain. And the process for his transaction to, submit on chain is that her transaction is going to go to the mempool, right? Now what is going to happen is like Bob is also, Bob is not as much smart as Elias in the class, but he's very, different kind of smart, like, he's very a hacker kind of a guy. Okay, so what happened is like Bob doesn't know the answer. So what he will do is he's gonna monitor this mempool for the transaction to find the answer. He's like, yo, I'm not the smartest one in the class, but I know hacking and I know the coding side. So what he's gonna do is like he will create a bot or something, and he's always gonna look into the mempool. So what he's gonna see, like whenever someone submits an answer, right, he's gonna submit that answer before that particular answer. But right, in this case Alice, before Alice, he submits his transaction with higher gas fees, and they submit the transaction, and both of their answers are in the mempool, right? Alice has also submitted one, Bob has also submitted one. So Alice also submitted one, but that is, she submitted it before Bob, right? So technically her transaction should go before Bob transaction, but that is not the case, right? Every both of their transactions in the mempool, and in the mempool, Bob has provided 50 GUI gas fees, and Elias has provided 15 transaction gas fees, right? So in this case, the validator, they basically want to create more money, right? So what they will do is basically they will include the Bob's transaction before Alice's transaction. So and then Bob transaction will get executed before Alice due to the higher gas fees, and then it will be submitted on chain. So in this case, Bob won the transaction, won the prize or whatever. He gave the answer first because on chain transaction, his transaction was shown first. So in this way, he created this value, right? It's created the value, and this is basically called front running in simple terms, right? This basically encouraging miners to include my transaction first, by allowing them benefit to price movement caused by the original transaction, right? So this is like the simple example, right? So yeah, nothing much to mention here. Hope you understand what front running is now. We will, go through different actually DeFi related examples in the future, but I just wanted to give you like a basic, very simple example so that you understand it. Okay, so this is front running. Now talk about back running. So what is now back running? So back running is like, so front running was a transaction before someone says transaction, and back running is like inserting a transaction just after someone's transaction, right? Now, one of the example could be, again in the mempool, there will be multiple transactions, and you are gonna, make sure that your transaction is after this transaction. So, Li in this case, like Li submitted a transaction, so there can be any way that this, the Bob can basically generate more value by submitting its transaction after Li's, like just after Li's, right? So this can be the case. Okay, so as in the back running, right, the user's transactions, goes first, and after that, just after that, there will be a target transaction. So one of the example that could be is basically maybe buying, large quantities of token as soon as it is launched. So there is a token that is launched, and just after that, there is someone who is, buying another token, like a large quantity of that token, right? So this can be an example of back running. There can be multiple examples. So, so basically front running is like submitting a transaction before the user transaction, the targeted transaction, and back running is like submitting a transaction after the targeted transaction, right? So in both the way, the motive is to create value, right? Motive is to create more and more money, right? By the validators, by the miners, or who, these people. Cool. So this is back running, and now moving to sandwich attack. So sandwich attack is basically mixture of both front running and back running, right? So it's like attacker, they're going to place a transaction before and after the target transaction. And this can actually manipulate the price of a token in a way that allows the attacker to buy and low the high, prices, basically. Let's get into the example, and I will explain to you with this example. Okay. So Bob goes to Uniswap or any swaps, right? What he wants to do is he has ETH. He has ETH in his wallet. He wants USDC. He wants to swap that ETH with USDC. Okay, so he goes to the swap protocol, and he swaps it, and his transaction goes to the mempool, like the public mempool. Okay, and then after that, what Li saw is that, hey, Bob is trying to swap 100 ETH for USDC. Okay, and so what Alice will do is, she will submit another transaction where she wants to also swap 650 ETH for USDC. Okay, now this transaction will be submitted. Okay, and what she will do is, like, she's very smart, so she knows that if she will provide more gas fees than Bob, then her transaction will be included first, and his transaction is already in the mempool, right? So she can see how much fees Bob has provided. So she can provide the, more than basically just the minimum, more than this Bob's transaction, right? And after that, she will submit another transaction. So she will, submit two transactions. One is that she will also swap ETH for USDC, and another transaction 3 will be swap USDC to get, ETH back. So she is like, again, she is doing the same thing. Like, she is again doing one transaction, she is swapping ETH to USDC, and again in the second transaction, she is gonna swap USDC to get his wrapped ETH back, right? But in between, in these two transactions, there will be a transaction of the Bob where he is also trying to, swap ETH for USDC. So what is actually happening here? Okay. So this transaction 2, that is by allies, that is going to go first, and after that, the transaction of Bob is going to go first, and then the transactions for allies, the transaction 3 is going to go first. So how this Uniswap liquidity pool basically works is that, if there is one token more in that particular pool, right, the price of that pool is going to basically go down, and right, so you might get more price if you swap. So following this example, right, so transaction 2, what Alice is doing, like, she is swapping ETH for USDC. Like, this is the same thing that Bob also wants to do, right? So when she swaps ETH for USDC, right, so she is basically submitting ETH to that liquidity pool, and she is gonna get USDC, right? So if you're submitting more ETH to that pool, and there will be less USDC, right? So the price of ETH will go down, right? So in the next transaction, so she has already swapped $63 of ETH for USDC. In the next transaction, when Bob tries to, swap ETH for USDC, he is gonna get less price. Why is gonna get less price? Because, Alice has already swapped $650 worth of ETH for USDC. So she knew that Bob is gonna do this, right? So before that, she already swapped, $650 worth of ETH for USDC. What this has done is that this has reduced the price of ETH. So this is like the loss of Bob, that he's gonna get, less USDC in return, right? So yeah, after that has done, again what Alice is doing is basically whatever the USDC she got from the transaction 2. So she she swapped this worth of ETH to USDC. Again in the transaction 3rd, this USDC she got from this transaction, she's again gonna convert this to wrapped ETH. Why? Because in this liquidity pool now there is more wrapped ETH, right? So if you're gonna provide USDC to that pool, you're gonna get more value out of it, right? So she is basically swapping her USDC to get more money out of it, because the price of Ethereum is less, right? So she can basically buy Ethereum for a lower price, right? Simple as that, right? So she now swapped USDC to the transaction, whatever she swapped in transaction 2, is her first transaction. In this way, the loss is of Bob, the user, basically, right? So this is the way that these sandwich attacks occurs, right? In this example also you can see like simple, like there's some simple again different transactions in the block, right? There's transaction 1, transaction 2, transaction 3, and 4, right? So transaction 2 will be like MEV bot executor, like allies basically, in this case the MEV bot. So her transaction is there, and then the user transaction that is executed at a worse price, right? So the user transaction is in between, right? And then again, there is a transaction by the MEV bot that closes that position. Like, for example, whatever she did in transaction 2, she's gonna, do the opposite thing from this. She's gonna basically close the position with better price, making a risk-free profit, right? So there is no risk involved in this, right? The bot has made the profit. The validator the block builder has made the profit, and there's like zero risk involved, right? So this is how the sandwich attacks works, and like it's one of the most harmful types of MEVs, like sandwiching attacks, and it has been executed like more than 480,000 times, profited miners at least like $190 million at the expense of users over like last 12 months. And yeah, so this is like one of the things, one of the attacks that happens. One of the example homework that you can actually do research on is poisoned sandwich, right? Poisoned sandwiching, right? So this is like also one of the interesting thing that you might want to learn on. So just go and Google about poisoned sandwiching. What is that? Okay, moving forward to our different attack, the new attack. So the next strategy is the arbitrage and the liquidation, right? So these attacks take advantage of price differences, disparities between different taxes, the different taxes available, right? So it's pretty sure like there will be the price differences between, like the price difference will be like very less. In the flash loan cash course, we actually did arbitrage. So if you want to actually perform arbitrage, go and check out my last cash course on flash loans. So it's amazing, right? And an attacker, so in this case, like an attacker can simultaneously buy a token at a lower price on one DEX and sell it at a higher price on another basically DEXs, right? So this is arbitrage that happens. Like Bob sees this, basically the apples are cheaper in another town, so he buys them from another town and then sells them in his town basically at a higher price. So this is in simple terms what arbitrage is. Okay, and now what is liquidation, right? So all these decentralized lending applications in the DeFi ecosystem, applications generally have this minimum require collateral value, like collateral balance for all outstanding loans, right? So if you take a loan out of the DeFi application, the lending and borrowing protocol, there will be like a minimum collateral balance required, right? And so should the value of collateral, if that goes down below the minimum, minimum price, the application will automatically, sell the locked collateral to prevent the overall system from getting, insolvent or basically going to the bad health, right? The liquidation is basically, it is seen as the positive outcome of the DeFi ecosystem. That's why, sometimes people say that MEV is bad, but it's not the case. MEV, liquidates position, which is good for maintaining the good health of a system, right? If you're not, even if you're a beginner, if you don't know anything about DeFi, check out the stablecoin crash course where I explained about how the MakerDAO and the DAO ecosystem works, like the issue DAI tokens. So how the MakerDAO actually works. Once the user, if you want to mint DAI, you have to submit collateral and you open basically a CDP, and if it can get liquidated if the collateral backing the DAI is not enough, right? So again, coming on to the example in the diagram, you'll be able to see this MEV type liquidation. Okay. So there is a searcher one. Searcher is basically, we'll talk about searcher in our next slide, but basically you see searcher right now as validator, right? He's gonna make the block, right? He's involved in that process, okay, making the block, okay? He's involved in that process. He's one of the component. So what he's gonna see is that he's gonna identify a liquidation of 1,000 DAI, okay? So basically, there is a lending protocol, and he submitted, he minted 100,000 DAI. He submitted collateral, but the price of the collateral that he submitted, for example, ETH, has gone down, and it is not enough for that DAI that he has minted, right? So there's a liquidation opportunity, right? So what he's gonna do is he's gonna see that right here, the price of Ethereum goes down, right? So he is gonna purchase the liquidation assets on auction by lender at like a 10% discounts, right? And after that, he's gonna sell that 1,000 DAI at a market value, right, to onto the DEX actually, right? And then he's gonna get a profit of like 100 DAI because he auctioned by lender at a 10% discount, right? So in this way, all these the searchers basically, they liquidate these positions and they gain price. So this is like one of the strategy how they make money, and this is not bad, right? This is like improving the health of the ecosystem, right? This is not something that is bad. I know the sandwich attacks may be bad, I can understand that, but this is for maintaining the system's health, keeping the system healthy, right? I have this statistics, like in 2022, over 47.5 total revenue was generated by arbitrage. Arbitrage, we just discussed, price disparity, buying and selling it, buying at lower price, selling at a higher price, or opposite. The liquidation is 10.82%. That was 33 million. The arbitrage was 47.5. So arbitrage is like heavy market, and then there is sandwich that was 41.7%, right? So yeah, it is like 2022 records. 3 months have involved in risk country. This was researched by Argenfi, so I'm just trusting them. And as I said, like with the increased adoption of the DeFi ecosystem and growing liquidity within the DEXs over time, more and more, more money is flowing to this DeFi ecosystem, right? So more and more adoption is taking place, and the currents are like profitable of these arbitrage opportunities have increased. A lot of opportunities have been increased in the arbitrage system, and lending and growing competition between these arbitrage bots. So these people are not doing it right. Just to understand technical, they're like bots available who always looks for this. People are not always actively looking for these things, right? They create code, they create bots that are there to scan these and then find these and then liquidate positions. Okay, so there are bots, and these bots are competing with each other. So whoever writes the best code, the optimized code, will get this prize. Okay, so they all are fighting. Cool. Now we've discussed all these strategies, types of MEV attacks, front running time bandit attacks. You can Google it. Like, it doesn't really happen after the merge, and I already told you, like, this video is like after the merge. Like, please read about time bandit attacks. What is this? What is uncle block? what happened it actually happened with Ethereum multiple times, but if I'm not wrong, that this can't happen after the merge. If I'm wrong, please comment in the section. But I don't think so. It can happen after the merge. Okay, read about Uncle Blocks and how Uncle Blocks affects the blockchain. Cool. Now, what is the problem of MEV, right? So as I said, like MEV is not bad. It is actually also good, but sometimes it can be very bad for the user, for user experience, as we seen in the example of the sandwich, like in the DeFi ecosystem, it can be very bad. So what are the problems right now? One is centralization, right? So MEV is basically a threat to decentralization due to the nature of MEV marketplace. If left unchecked, it leads to centralization. Like, so whoever these validators and building validators who are building the block, right? So these can become a centralized process, and these few block builders are gonna get the more profit rather than few other validators, right? So we want to make it as a decentralized process, right? The motive of all these things like blockchain and Web3, whatever, is decentralization. If we are not even able to make decentralization in every layer, like what is the use of it, right? So we want to make it as decentralized as possible. We want to get everyone's equal support here, and we want to provide equal opportunity to everyone. That's why we want to make this process decentralization, and we are the community, the Ethereum community, is actually working on this. Okay, we will see how that is going to take place in our future slides, which is like very interesting. Like, if you are till here, please watch that. Like, that is actually the main thing. Okay, this is like the simple thing that everyone knows almost. If you didn't, then I hope you learned about it. The worst user experience. Some MEV strategies like sandwiching results, as I said, and worst user experience. Like you've already seen in the example, like this can be unprofitability for the liquid providers on certain blockchains. Dominant strategy for searchers is to simply spam transaction to extract value. And so in different blockchains, what they do is validators or whatever, the searchers, basically those who are included in that block building process, they simply provide spam transactions on to extract value. They're going to provide multiple transactions just to get the value. Then this time this increase congestion and increases the transaction fee. So definitely user experience is worsened by MEV, and we have to solve this together as a community, and the researchers are working on this, and you can also work on this. After watching this crash course, you can also work on this. I hope you will get enough understanding of it, and I will provide you the opportunities of how you can what are the links. I'll provide you all the links where you can go and contribute to. Okay, what is Flashbots? So now moving towards deeper topics. What is Flashbots? Flashbots is so companies like Flashbots, they help create rebalance in the ecosystem by searching the developing protocols that attempt to mitigate this negative externalities posed by MEV. Flashbots are like those people only who created the paper that we saw in the history, Flashbots 2.0, right? And they plan save Ethereum from MEV by building sharing tools. So they have built multiple tools, MEV Get, MEV Boost. We will discuss all these tools in the future. So basically, they are like research and development organization working to mitigate the negative results of the MEV and creating a better blockchain. And around 90% of Ethereum miners, all the miners or the validators, basically, they have adopted the Flashbots, and companies' core software, MEV Get, right? They're using it, and MEV Relay, right? Along with its open source guides for helping people become searchers. You can become a searcher. Has helped democratize MEV by lowering the barriers to entry, right? So they've been doing good work. I'm not going to go deep into this slide because we haven't covered those topics. So they have been doing good work. If you want to, learn about them, go to Flashbots website. Just Google Flashbots. I will provide the link in the description. You can learn about their different products, what the process they have done. And, it can be a good starting point for you in terms of coding and, executing it. We will also use Flashbots in our coding section. Okay, moving on to our next topic, that is PBS, proposer builder separation. Okay, so what is proposer builder separation? Okay, so you are now already aware of that blockchain basics, like how that works. If you are not, just please go back and again repeat like how blockchain transaction actually works. Okay, so proposer builder separation is basically a proposed solution to all the challenges that we discussed of censorship and MEV attacks on the blockchain networks, right? The concept of PBS is rooted in the idea of separating the role of block construction and block proposal within the network itself, right? And this separation of duties is designed to create more decentralized and secure network while also addressing all these issues of MEV. Okay, so in a blockchain network, especially talking about Ethereum, we have talked about like there is all the transaction goes to this mempool, and then mempool, the validators, the block builder, they create a block, they include your transaction, and that goes onto the blockchain, right? So now what this proposal is saying, like it is and this is a very critical operation, like transaction processing and block creation. It's very critical, right? This is the main thing, right? So in early blockchain protocols like Ethereum, all these like validators were assigned two key duties, right? So these validators, as we talked about, who are going to pick Ethereum transactions from the mempool, they were assigned two duties. What those duties were? One was that create the block, like build the block and propose the block to the blockchain, right? Also like create one block, right? Create that block, right? And then propose that block onto the chain as well, right? That we discussed. Let me show the diagram. So, this nodes will basically, create the block, create a proper block, and then propose this block to the blockchain. So it gets included, right? So these are like the two activities that a validator has to do, right? Now, what this proposal is trying to do is the same validator now would gather the pending transaction, like same validator, and determine the block contents and order transaction, fully construct new blocks, right? So that validator only used to gather the pending transaction, determine the block content, and order transaction, fully construct the new block and propose it to the network, like in this way the block is it gets joined as the blockchain, right? So this is how in traditional blockchains that used to happen. Okay, now what we are trying to do is we are trying to separate these two positions, basically these two key duties, right? These two key duties we are trying to separate it, and we want these two key duties, that is the block building and the block proposing, to get to two different people, right? So rather than a single person, single validator doing these two key duties, we want them to get separated and two separate entities to perform that duty, right? Now, what is block proposer? Simply, like block proposer is the body of the block, right? The body of the block is all the transaction that will go into that block. Simple as that. That is the block body of that block, right? And the builder, like the building of the block is the proposing of the block is basically proposing that particular block to the blockchain, right? So these are like the QD duties, right? So now what will happen is that Ethereum mempool, there will be a builder that who will receive a bundle from searcher and from searcher. We will talk about what searcher is, right? But these builder and proposer. So this builder is gonna build the block, then this builder is gonna give the block to the proposer, right? And and then the builder gets the proposer basically includes that block to the Ethereum chain, to the validator, like whatever the to the blockchain, whatever blockchain it is. Like if it's Ethereum, then to the Ethereum. It's as simple as that. The basically fundamental of PBS is to make sure that these two key duties, the proposing and builder, is separate. Okay. Now we will discuss the architecture of it in the future slide. But the main concept is to make sure that these two key duties, the proposing and building of the block, is different, right? Building the block means all the content that are into that block, all the transaction that is into that block, right? And proposing it means that proposing it to the blockchain. Okay, the new block has been added to the chain. Okay, now there are two approaches to be implementing to the PBS. And before moving actually to this approach, let me tell you, like on the PBS side, so the work on PBS, this proposal was introduced by Vitalik, I guess long time back, and now still the research is still going on, right? So the recent, the recent one was that 2-slot proposer builder separation that was by Vitalik, right? Slot means 12-second slots. That is the time where the validator, basically the builder has the time to propose the block, right? That is the slot, the 12-second one. Okay, so this is like the research is still going on, right? So you can actually go to this article. I will provide the link into this, like 2-slot proposer builder separation. We will discuss it later. So you can actually go through and read this, like what are the different types, like how is this going to implement, right? So still discussion is going on. We have talked about the essence, like what is the goal, what is the motive, but to implement it, right, there are different strategies, different techniques basically, right? So these techniques have been discussing, Vitalik has been giving ideas, community have been discussing there. So you can actually go and comment in this as well, and you can do your own research, you can get involved, whatever. Like this is the beauty of the Ethereum, that it is all open source, it's all decentralized, you can get involved in the research, right? People will listen to you if you're talking actually good. Cool. So before talking about actually the the PBS, let's talk about this only. So there are two approaches to be implementing the PBS. Okay, one is out of the protocol PBS and one is the enshrined PBS. What is the difference between that, right? The out of protocol PBS is basically implementing this proposer builder separation outside of the blockchain, like not in the core client itself, right? There is a blockchain running, the client running, right? And implementing PBS into the protocol is called enshrined PBS, and proposing a solution out of the protocol, like not disturbing the main code base, it is called out of the protocol. Just like account abstraction, ERC 4337. Remember, in ERC 4337, what we are trying to do is, we are trying to implement account abstraction, out of the protocol. Like it's not native account abstraction. Like ERC 4337 not a native account abstraction, right? So similarly, out of the protocol PBS is like building another solution to implement PBS out of the protocol, right? So MEV Boost is an existing third-party solution from the Flashbots that we will talk about, and that operates outside the Ethereum protocol. And 90% of the Ethereum blocks has been produced with that, right? Right now, the current, whenever I'm recording this, it relies on like centralized relays. That is like one of the problem with it, but it is the solution for now. And the next is the enshrined PBS. It is the advocates for integrating PBS into the consensus layer of the Ethereum protocol itself. It aims to address the limitation and risk associated with the relying centralized relays. So, right. So, current scenario is this out of the protocol PBS is already working in live. MEV Boost protocol is, third-party solution by Flashbots that is already there. We will discuss it. And the enshrined PBS, it is basically better version. It solves the problem of whatever the problem this out of the protocol PBS, the MEV Boost is showing us. There are difficulties with that. We will discuss about it. Censorship, decentralization, whatever. And and once this is done, and this will get done. The research is already going on. I've showed you the paper. So the work on this is already going on, and this is already live. So this will come soon, but it's going to be the same. So we will discuss the architecture of the out of the protocol PBS, and it will be almost same as the enshrined PBS. Cool. So these are like the two ways, and let's move forward. Ethereum roadmap. Cool. So in the Ethereum roadmap, I have, if you Google just Ethereum roadmap, you can see it, the Vitalik's tweet. So PBS is like one of the most important module on the Ethereum roadmap. There were like different partitions, the surge, the merge, the surge, the scourge, right? The merge has already happened at the time I'm recording. There was something called surge and then scourge. The third one was Scourge. Like the Scourge is the one basically where he talks about where this will be implemented, like in protocol PBS, right? The roadmap is not really clear. I didn't got the better picture, but yeah, it says like in protocol PBS, and yeah, it is one of the part of the Ethereum roadmap. And this one right there is like the chart one. Left is the Ethereum roadmap by Vitalik. This one, and the PBS roadmap by Mike Nutter. So Mike Nutter is one of the researchers. He's working on PBS. So he also gives this roadmap, like what is 2-slot, which you just discussed, Vitalik's paper of 2-slot. We will discuss it later. PEPC, we will also discuss it. What is PEPC with the eigenlayer, how it's that solving. The MEV Boost, we will discuss this. And yeah, right. So this is like a deep side of the PBS roadmap, right? So yeah, just wanted to show you, like this is like the potential paths of PBS R&D at this stage. This is like the latest thing that I'm showing you, right? So yeah, cool. Let's now move forward to actually MEV Boost. What is MEV Boost and how is that running, right? So before Flashbots, the only stakeholders in the ecosystem were searchers and the miners, like the mining pools, right? After I'm talking a little bit about the history, not today. After like MEV Geth is one of the protocol that was released by where relays were added, right, to the MEV extraction supply chain as a trustless communication channel between the miners and the searchers, right? The move to proof of stake brought it with sophisticated level of staking providers causing consensus level centralization. Okay, so when the merge happened, when the Ethereum blockchain moved to proof of stake, right, there was a discussion that we need this PBS, but this PBS is not really ready. So in between, like, there should be a solution, right? So that's why Flashbots actually introduced MEV Boost to separate this role of block proposer and block builder, right? And avoid centralization at the consensus level. So you might be thinking, why MEV Boost is there? It is not proper, but we need this is like the in-between solution till the Ethereum developers are working on the in protocol enshrined PBS. Till that, we need out of the protocol solution that is MEV Boost. That is why Flashbots, right? So after the merge, this was very much required to avoid centralization, right? But it is not perfect. Okay. So MEV Boost is basically early implementation of the proposer builder separation. We are separating the builder and the proposer, right? On the Ethereum, any validator node has the capability to run MEV Boost. So any validator node, they can run this MEV Boost tool that allows them to receive bundle transaction constructed by builders such as Flashbots. These bundles come with incentives in the form of the tips or brides, right? We will discuss about it. Currently, 90% of the Ethereum POS blocks use MEV Boost for block building, resulting in increase of proposer benefits by 55%. Okay, so like as I'm saying, as of now, the validator, whoever is running it, they can actually run the MEV Boost protocol side by side, the tool basically, right? And they can take part in this particular process: the searcher, the builder, the user, and then there will be so there are 4 major components. One is the user. User are just who are doing transaction, and after that your transaction goes to the searchers, and then builders, then relay, MEV Boost. We'll talk about it. Okay, don't get confused. One more thing also to remember is that consensus client and execution engine is different. So before the merge, if I'm correct, there was only one client that a validator has to run, right? The client was Aragon or the Geth or the Nethermind client, right? But after the merge, there are like 2 clients that a validator node has to run: the consensus client and the execution client, right? So these are like 2 things that validator has to run, and along with that, to make profit, to use this MEV Boost tool, you also have to run this MEV Boost tool side by side. Okay, so you just understand the diagram. This is like the validator node that is running the consensus client and the execution client, and then there is like a builder API, whatever, for this communication, right? And then this MEV Boost is basically this validator only has to run this tool, right? To get profit from this particular tool, like get another person to build the block for you to optimize the MEV opportunities. Okay. Now moving forward, like don't get confused. Let's discuss the internal components. Okay. So on the block producer end, okay. So understand the diagram. There is an execution layer client. There is a consensus layer client. Okay. So this is like two clients that a validator has to always run. Right. Cool. And now they are on the block producer side. Now what is going to happen is that the validator will connect with this MEV Boost software. Okay. This MEV Boost software, which is gonna help him to get connected with the builder who is gonna build the block. Okay. Now, Ethereum public mempool. Okay. This is like the mempool that we showed. All the transactions are here. So what is gonna happen? This searcher is when empty. Like there are 4 main things involved here. Actually 3 main things, right? 4 main things. One is searcher, one is builder, the other is relay, and the other one is proposer. These are like 4 main components of MEV Boost or PBS. Okay. Now the first one is searcher. Searcher is the one who collects the transaction from the mempool. Okay. He builds a bundle of those transactions. After that, he submits that bundle of transaction to the builder. Okay. Now builder, creates a block of those transactions, and after that it submits the transaction to the relay, right? And from the relay, the block goes to the block proposer, basically the person who is running the execution client and the consensus client, also known as validators. Okay. So this goes to the validator, right? Now this is like the simple flow of how MEV Boost protocol works, and also this is like a win-win situation since validators, like this validator, gets to keep the portion of the MEV profits, often a significant majority, like up to 99% in atomic MEV, right? And also without investing significant amount of strategy to development, and the searchers get to constantly extract value out of the transaction without 32 staking ETH. Now, what do I mean by saying that this is a win-win situation for both of them, right? So this is like the validator and this is like the builder one, right? So just make sure that these 2 things are separate. This is like the proposer, this is the builder. That's what the PBS is trying to do. Proposer, keep the proposer different, keep the builder different. Okay. So now this is a win-win situation for both of them. Now, how is that win-win situation for both of them? Is like that the validator doesn't have to invest much of the time to create this strategy, right? We have talked about different strategy, sandwiching attack, front running, right? So all these strategies requires time and the power of the validators to do this, right? So in this way, on the validator side, the proposer side, he's able to give that work to another person who will do it for him, and he will make sure that it is like more and more profitable. That when we are going to separate the work, obviously the person who is more basically expert in a particular thing, like he will be able to extract more value, right? And if we are able to extract more value, then this validator, they are gonna get more out of it rather than creating their own block, right? And on the other hand, why is a win-win situation for builder? Because they are able to generate value without staking 32 ETH, right? To become a validator, to become a proposer in the Ethereum blockchain, you have to propose 32 ETH to propose those blocks, right? But if someone doesn't have 32 ETH and if they want to participate in this program, how will they do it? They can become a builder, and they can become a searcher. They can build the block and they can provide the block to the validator. You provide some value to the validator, like whatever the tip, whatever you want to provide, and then you also get to keep the profit, right? So in this way, this is a win-win situation for both of them. Okay. Again, step 1 is very simple. Step 2 and 3 have divided into 4 steps. Step 1 is very simple. You are a user. Anybody goes to Uniswap, whatever dApp, and then they just intent. They pass the intent to the dApp, whatever they want to do, and then that call data goes to the wallet, whatever wallet you're using. Your MetaMask pops up. You sign the transaction. You approve the transaction, you sign that, and your transaction goes to the RPC. So your RPC, like your wallet has this RPC on the back end that is like a connection between your wallet and the blockchain, right? One can also run their own node, but whether you use RPC or one can run their own node, right? So after that, it goes to the searcher. Now searcher is like the part who is gonna create a bundle of transactions. Now what is that bundle of transaction? We will discuss it after this, and after that, that bundle goes to the builder. Now builder is gonna build a block, and after that, the builders is gonna submit that block to the relay, and from relay, the most profitable block goes to the proposer. Okay, and here, if you don't understand like step 1. Just go and read more about dApps and how blockchain works. You will be able to understand it, but yeah, it's just pretty simple. Okay, and this step 2 and 3 are like simple one. Just make sure that you remember this flow. Okay, searcher, builder, relay, and proposer, because now we are gonna discuss searcher, builder, relay, and proposer in depth actually, right? How can you become a searcher? How can one become a builder? What happens under the hood? Internal architecture, each and every technical things, code base, right? And the relay and the proposer. Okay, so just remember this flow. Just you can take a screenshot, save this, whatever, but just remember this flow, right? Transaction goes to searcher to builder, searcher to builder to relay, and then relay to proposer. Okay, now let's discuss each and every single topic. Now let's first discuss searcher. After discussing every single component, I will come back to this diagram. Okay, so you get a proper thing, knowledge about it. Cool. So let's discuss the searcher. So as of now, your transaction is gone to the RPC, right? You've signed the transaction. Now from the RPC, your transaction has gone to searcher. Now what is searcher gonna do? Okay, so searcher, what is searcher? So searcher can be anyone that uses the blockchain looking to gain a profit by reordering, inserting, or censoring transaction in a block, right? So basically, searchers scan the pending transaction that is visible in the mempool, right? And compete against each other for opportunities to execute their MEV strategies. Okay, so there are like anyone can be a searcher. You don't need to be a specific person. Anyone can be a searcher, right? And there will be different searcher that will compete against each other to find the maximum value that can be generated from reordering the transaction, right? So now you must be asking all these questions like, who are these searchers? Can anyone be a searcher? Yes, anyone can be a searcher. Why do they participate in the extracting game? How do they ensure that strategies get executed? How exactly do they make profit? What makes searcher competitive? We will discuss it in all these questions in the next slide. But as of now, like there are also, although there are limited number of opportunities to extract value from the reordering transactions, and the fastest searcher to identify this MEV opportunity is often the searcher to earn the most MEV. Okay, so to maximize the earnings, competitive searchers will write scripts to automate this task of exploiting easily identifiable opportunities for the MEV. And in addition, searchers may run dedicated hardware or subscribe or to paid services that offer low latency to take advantage of the pending user transaction, right? So what here I'm trying to say is that this searcher, like this is a searcher, his job is to always look into this pending transaction, right? His job is to always look into this pending transaction and make sure that all the transactions, to make sure that he can extract the more and more value out of these pending transactions, right? So he may run a dedicated hardware, he may run his own node, he may subscribe to paid services, because as he to offer the low latency views, right? So you don't want any latency in the transaction that is coming onto your mempool, because as I already discussed, there is no single mempool, right? There is no single public mempool. There are multiple mempool. Like every node, if you're running a node, you will have your own mempool, right? So whoever is running the better hardware whatsoever, he will have low latency, and this gets an advantage over the person who is the searcher who is getting the transaction later in his mempool, right? So this can be the same, right? This can be the same, and this is like very competitive, right? So these people run the searchers always run like dedicated scripts and bots, whatever, to maximize the earning, right? And to outcome, other searchers like seasoned and sophisticated searchers may deploy complex strategies involving multiple token swap, bots, manual searching, on-chain activity to achieve higher and higher profits. Like, so these searchers deploy like complex strategies and involving multiple token swaps. It's not an easy job, right? You have to be an expert on this. Like, and how can you become a searcher? Let's really discuss the searcher's MEV process, like how a searcher thinks, how are things going inside in a searcher's head, right? So basically, the job of the searcher is to create a bundle, right? Just simple job, just to remember, like the job of the searcher is to create a bundle of transaction, right? And to execute MEV opportunities, there are like few key skills the end concept a searcher needs to possess. Okay? Now there is the discovery period. After that, so basically the searcher always discovers the pending transactions here, right? Then he understands the opportunity, right? Now, to be a searcher, no, you have to be an expert on DeFi to understand how transactions works, how EVM works, right? Because then only you will be able to understand what is happening, right? And after that, he understands the opportunity, and then he determines MEV prevention or determines the competition, because there will be competition. And then there will be like monitoring and logging phase, because you have to make sure that you're always monitoring it. And then there is execution strategy and combining monitoring and execution strategy, right? So in addition, like it is very important for searchers to have like knowledge of DeFi and programming languages like Python, JavaScript, Rust, basically, etc. Then these skills are important because searchers need the ability to extract information from the sending transactions to the blockchain, right? So it's very important, right? Let me tell you a few more things. Like, so if you want to connect with the blockchain, you're sending any transaction, right? So there are two things that you can do. Either you can use services from RPC provider like Alchemy or QuickNode, Anchor, right? So these are companies, the organization that is providing you service. Basically, they are running the node for you, and you can access that node. The other option is that you run your own node, right? So there are two options, right? Now, if you use, so there was a research, actually, there was someone who created a script for that. It's very simple script, right? So if you're running an Alchemy using an Alchemy node, if you want to see the transaction mempool, then it was like it was taking more time than actually running your own node. And although running your own node, in running your own node, there are different clients. There is Geth, there is Anygon, there is Nethermind. So now searcher always look which client is better for you. Like, so you might want to use Anygon because it shows you better. It gives you low latency, right? You want to use Nethermind. So just these searchers are always looking to reduce the latency. Like, they want low latency because they want the transaction to be visible in their mempool as soon as possible, right? So as low latency and the most optimized their code is, and their code can be written in Rust, they can be written in Python. From what I have heard and read, Python and Rust are like two more important things, like two more optimized one. Rust is the most optimized, so most of the searchers script are in Rust. Okay. Yeah. Thanks for that short session. Now move forward to the crash course. Like, what is the flow of the searcher MEV process? Again, flow. We are discussing searcher, right? So in searcher, what is the job of searcher? Like, flow of searcher's job. Okay. Okay. So the first most thing is, and this is post merge. Okay, this is post merge. So first thing is the transaction is watching phishing from the public mempool. The first step is this, like users sends their transaction to the mempool with the hope of security, securing a spot in a newly added block. You want your users want to add their transaction to the block, and these transactions are then routed to the public nodes worldwide. Okay, and how it's important to note that these mempool lack synchronization and resulting in the absence of, as I said, there is no global mempool. So for those of you who are interested in actually exploring the source code for the mempool, actually let's go to the get client and let's see the code base. Okay, that's an interesting thing. Okay, let's actually check out the mempool code. Okay, so I'm on the, I hope you're able to see my screen. Yeah, you're able to see my screen. And now I'm on the actually the get client code base. Okay, so now I'm going to take you to the file, to the mempool. So transaction pool, it should be that. Sorry, transaction pool. Oh, cool. Yeah, it's there. So if you want to explore like the mempool, actually mempool in the code base, in the code terms, that this is in Golang. Okay, so this is like the transaction pool. This is the actual mempool, that live mempool. Okay, this is the code base for that. So if you are someone who wants to become a searcher or something, then yeah, this is something that you can look to. Reserve just different functions, close loop, whatever. I don't even fully understand myself, but yeah, there's just different functions that you should, if you want to become a searcher, then you should be just aware of this code base. Okay, yeah, okay. Let's move forward to the theory. We will share the code base later. Okay, cool. So as I said, like, so where we were, like how it's important to know that these mempool lack synchronization. As I already said, like there is no single mempool, right? So these mempool are, these transaction pools in Get that we just saw, right? So these are like the transaction pools, and searchers sometimes actually, they run their own node, and others pay to like mempool services. Like there is a company called Block Native. So what Block Native does, it is basically for searchers to provide an API to receive all that mempool data in a faster terms, at a minimal latency, to run their own nodes. So you don't need to run their own nodes, right? So as I was discussing before, right? If you're using like RPC services API like for Alchemy and Anchor, then it will be very slow for you. And if you are running a node, then it might be like you need all these specification, 30 GB RAM, whatever, depends on the clients, right? So rather than running your own node, and you also want low latency, so what these companies are doing is they are providing you APIs to, so you don't need to run your own node, and you also get low latency as well, right? So it is creating, this is like a whole network now, a whole new ecosystem now, right? So that's just funny. And and to receive and not to run their own nodes, as I said, like latency optimization is very important for searchers, and because it actually allows to compete with other opportunities, and just before the end of the 12-second slot. So everything is happening in like 12 seconds. Okay. So yeah, and this is like the first steps that the searcher is looking into the mempool. We just saw the file. And as I said, that you need something, a API or run your own node to, get access to this mempool. Okay. Now, next step. What is the next step? The next step is running a simulation, right? So searchers will proceed to run a simulation on the chosen transaction using their privately owned nodes. Okay. Nodes are basically whatever. If you're using basically if you're using the API, you can use tools like REVM. So the purpose of this simulation is to observe how the execution of the selected transaction will impact the state of the blockchain. By meticulously analyzing the opcode, searchers will gain insights into how transaction will unfold, right? And to receive, like one approach is to run a simulation, and creating a simulation would be to run a locally hard-forked mainnet, right, where each transaction can be executed with an isolated EVM environment. By meticulously analyzing the opcodes, the searchers can actually gain an insight of how the transaction will unfold, right? So, to facilitate this process, searchers can employ tools like they can run their own tools like REVM or Arbiter, right? So it's like they're running their own EVM to make sure, just to see like whatever opcode, just to, optimize, not to optimize, just to see how these opcodes are, to analyze these opcodes, how are they running, what is happening, right? How the transaction that he included in a bundle, right? So he basically, the job of the searcher is to create a bundle, right? So just to simulate it, like what will happen if the bundle unfolds, he is running his own EVM to make sure how is this working. So it's basically a simulation that he's trying to do, right? So let me also just search REVM and show you guys what is that, right? So REVM is cool. Yeah, REVM is all you need. You can actually go to GitHub, right? So this is like REVM. This is like Rust Ethereum virtual machines that mostly searchers use to simulate all these transactions, to simulate all the builders, right? So yeah, just say it's EVM compatibility, stability, interfacing, and then blah blah. You can just check it out. Just need to move. I need to move faster to complete this course in less than 3 hours. So yeah, so I'm just showing you all these things. Just go and explore it. Okay, I'm just giving you an overhead of how things work. So if you're actually interested in REVM, this is like a Rust-based Ethereum virtual machine, which is amazing. And if you are a coder, developer, then definitely check it out. Okay. Moving forward, simulation. As I said, now the second step was simulation. That simulation is happening. Either run your own hard-forked mainnet, or with an IVM isolated machine, or run these tools like REVM and Arbiter. Arbiter is also one of the things. You can check out Arbiter. Okay. Sending transaction bundles to builders. Okay. The third step is that, right? So if the simulated output that he did shows a promises, searchers will proceed to bundle the transaction together with the one selected from the public mempool. The purpose of this building is to ensure that their transactions are executed either before or after the public transaction, right? So after this simulation has been completed, it goes to the builder, and then basically the solution should be promising. No, if he created a bundle and if that bundle is not promising the MEV, it's not creating value, then why would he proceed forward? And if this simulation is successful, is promising value, then it will the purpose of this building is to ensure that there is transaction executed. So its transaction will be gone forward. And basically the purpose of bundling, why the bundle is creating, to ensure that their transactions are actually executed either before or after the public transaction, enabling strategies such as front running, back running, or sandwiching. We all saw that, right? And how much important is the flow, like the proper not the flow, the proper executed transaction. It should be properly executed and like step by step, and there should be a proper structure to that, right? So we want to make sure that they unfold like line by line, right? So this is very important. That's why it is important to create a bundler to enable these strategies like front running, back running. Your transaction should always be before that particular transaction that the user has done, or sandwiching, whatever. It should be in between his transaction should be in between your two transactions, right? So that is like one of the things. So validators will then execute the transaction within the bundle to specific order, and ensuring that the simulated transaction unfold as expected. So this is like the job of the builder. Now to accomplish this, searcher utilizes private relays where transaction bypasses the mempool and instead go through builders like Flashbots. Okay, so this so simple as that. Simulation is completed, and after that through private relays it goes to builders, and these builders are Flashbots. And then after that, like the validator with MEV Boost will propose a new block to the network. Now this is like after searcher's process. So searcher's work here is completed. He has submitted the builder, like the bundle, to the builder, and now the builder is gonna work like So any validator tool that is running that MEV Boost tool that we just discussed, so you have to run this, right? So you have to run this as a builder, and you get this bundle from the searcher, right? And the bundle will come with incentives in the form of tips or bribes. You have to provide it. That's how things work. You have to, if you're working together, so you have to, distribute prizes among you guys. And they will receive bundle transaction, propose a new block to the network. Simple as that. We are not going deep from builders into the builders and proposer component for now. We will go deep once we discuss that. Now we are discussing searchers, right? So searchers drops here is completed, like, and then the proposers is basically the proposer submits the block to the blockchain, and searchers earn profit from successfully executing transactions. So once the proposer submits the transaction to the blockchain, his bundle, the bundle of that searcher is correctly executed, then he gets the profit. Simple. And yeah, so this is the proper searchers MEV process. Hope you understood it. Now let's discuss some searchers fact. Okay, so few searchers fact are like the searcher has to bribe the block builder with a promise of a specific amount being paid to the validator. Okay, so in addition to like the builder receiving the searchers bundle, has to win against the other builders in the builder auction. Like there are two work. Basically, one work of bundle, the searcher is to build a bundle, right? And then it has to make sure that the bundle is included in the blockchain, because if the bundle is not included in the blockchain, how will the searcher make profit, right? He has created a bundle, but if that bundle is not executed on chain, then how will they will make a profit, right? So this also has to make sure that your bundle is included in the blockchain, right? So this is like also one of the things that needs to be taken care of, and this is something that is not in the hands of searcher, right? So searcher has to bribe the block builder with a promise of a specific amount being paid to the validator itself, right? So there has to be a bribe given to the block builder now, right? So because searchers have like little control over this, it relies on the rest of the transaction that the builder has access to. Now it's the builder's job is to make sure that the block is included, right? Now you must be thinking like, so as I said, like there are different builders, right? So there are different builders, and you must be thinking like the best way to make sure as a searcher that your bundle is included in the blockchain, it goes on chain, is to make sure that let's distribute all the all bundles to all the builders that are most of the builders that are provided in that are there in the ecosystem, right, in the system. But no, that is not the case. Why? We will talk about it when we talk about builders, like why. Yeah, one of the things I can actually tell you, like because there is no proper authority, there's no promise that builder might not take your bundle that you have created where the value is, right? And they might take it and they might run away and they create their own block, right? So this can be the case. That's why it is not the optimal strategy. We'll discuss it when we will discuss builder. But yeah, this is one of the things. The other fact is that theoretically, anyone with a computer and ability to code and a willingness to find opportunities can start working on MEV, right? Practically, yes. Like theoretically, yes. But practically, that is not how what happens anymore. It is tough now to compete with experienced MEV traders in this landscape. Like the more niche, the more opportunity, the more likely the searchers will be able to, competitive. Like, so it's not easy as of now. Like, if I'm not wrong, like 1 to 2 years ago, it was little easy because there was less competition. And now, like I'm saying, you can become a searcher. It's not like you can't become, but you have to get, you have to write more optimized code. You have to get more hardwares. You have to invest money in this, right? So you can be a searcher, but it's now hard to compete with just experienced MEV searchers and builders. Okay, you can become a searcher. Just go to Flashbots Discord server and you will find a searcher channel there. Just start exploring, dude. So as I said, like one of the things that this is because the profit opportunity is not enough like nowadays to attract the sophisticated teams. Like some of the searchers, what they do nowadays is that they focus on alternative chains. Like some focus on L1s, on different L1s like the Ethereum, whatever L1s are there, Solana, Avalanche, Flare, right? So these are blockchains. So some MEV searchers, they focus on a single blockchain, right? And some focus on L2s, right? There are so many L2s out there, and or new chain or application, right? So there was recently Frontech, right? So if you go and Google or search on Twitter about MEV opportunities on Frontech, on friend.tech, so these searchers were just targeting friend.tech and they made like millions out of it, right? So yeah, few searchers now these days they are just focusing on a single application, or they're just focusing on a single chain, right? To just maximize the value out of it, because you can't go everywhere now because it's a competitive space now, and this competition is going to increase day by day. Okay, cool. And the third one is searchers have deployed smart contracts on Ethereum, which contains actual code that extracts the MEV, like executing a DEX, and searchers bundle contains a call to these smart contracts. Okay, simple. So these searchers have already deployed smart contracts, okay, on the Ethereum chain or whatever chain, and which contains the actual code, right? So so you just get very less time to do this, right? So when you're creating a bundle, what will happen is that here is, suppose in a sandwich attack, right? So here is your transaction or maybe front running, right? So before the user's transaction, on top of it, there will be another transaction that is gonna basically call the deployed smart contract on the Ethereum, which is like, hey, the user is trying to get more and more ETH. Let's front run him and, do something else, whatever example, right? So do it before that. So just this transaction is gonna call that smart contract that is deployed on the Ethereum blockchain, and then and then that thing, that particular operation is gonna happen, right? So these contracts are deployed by the searchers, to execute swap or whatever in a DEX or whatever example. You can take any example, like buying a token Uniswap before a retail user. This is like example of front run that I just explained it to you, right? And the searcher's transaction that the searcher wants to extract MEV from, right? So as I said, like there are already deployed smart contracts on Ethereum that you just have to call and just swap it, right? So because you have very less time for that. Okay. One more thing that you can actually also that I want to tell you is that if you want to become a searcher, because this is the last slide for searcher, like it requires like sophisticated traders and engineers these days. And opportunities like arbitrage and liquidation, like front running, sandwich check, whatever, are among these like short tail of MEV strategies. And you have to get more proper hardware, spend more money on that. We just talked about RPC versus node. You have to run your own node. Don't use Alchemy RPC for that. Use like Block Native's API if you can get paid for that, and then use proper languages to optimize the bots and write the scripts. Use Rust or use Python, whatever. Like Rust is better, so go for Rust, and sometimes Python is better, JavaScript, whatever. Right? Just make sure that your code or your script is optimized, because this is a competitive space. Okay, cool. Now let's move forward to builders. Okay, but yeah, let's actually go back to the diagram. As I promised, here is searcher. Searcher submits his bundle to the builder. Okay, searcher's operation has been done. We have discussed everything what a searcher is doing. Now he's going to submit that bundle to the builder. Okay. Now, what is the builder's job to do in depth? Okay, I'm gonna go a little fast now because it's getting very broad crash course, and I want to complete it as soon as possible. I don't want to create it like for 4 hours because people get poor and they don't watch. So I'm gonna go a little faster now. Cool. So as covered in the previous section, like block builders basically collect transactions and search bundles, searcher bundles to provide block that they submit to the relay, which forwards it to the block proposer in that slot, right? We discussed the overall flow. So builders right now, you can say like it's the new stakeholder in the MEV supply chain, responsible for packaging a transaction in bundles from searchers, along with the individual transactions from the public mempool and private transaction order flow into a block, right? The builders are themselves searchers in some capacity, as the task of building a maximal profitable block does not depend upon re-earning transaction bundles alone. It also depends on simulating how block space not occupied by the bundles can filled up with profitable transactions from the mempool and other sources, right? So basically the job of the builder is to take the bundle of transaction from the searcher and also take transactions from the public mempool, right? So he can also take transaction from the public mempool. It's not just that he wants to that bundle of transaction into this block. He can also take transaction from this mempool as well, right? So yeah, and there will be different builders, like we have already talked about it, like and also the reordering searcher also sometimes act as a bundles. The block builder also act as sometimes as a searcher, because you have to make sure that the profitable transaction and included is the transaction, the bundle is executed in that way, right? So it's also the job of the builder. And while searchers may specialize in at the task of extracting MEV from a specific DeFi protocols, builders generally have like a wider view of eligible transaction for including in a specialized task of full block simulating from multiple sources. So as I said, like searchers sometimes just focus on single DeFi protocol, right? Specific DeFi protocol. But builder, like this builder has like specialized tasks for has a like broader view of the mempool or like all over the transaction, right? So these block builders like try to assemble a block that allows them to maximize the amount that they pay to the proposer of the next block. Like proposer, he's gonna get he's gonna submit this block to the proposer, right? From the MEV available, he has to provide some tips basically to provide to bribe the proposer so that he can pay more. His block basically gets executed on the blockchain, right? So builder needs to build blocks from non-overlapping bundles, basically meaning that the same transactions cannot be included twice in the block, right? So you have to make sure that. So it's not again an easy job. So searcher, suppose for example there is a transaction from searcher in the bundle of the transaction, and he can't include the transaction twice from the transaction mempool here, right? So he has to make sure that a transaction is not just twice in that particular block, right? So you have to make sure of that. So it's just not an easy job to do again, right? So these are the small things that are happening under the hood, okay? Right? So thus builders usually select like the searcher whose bundle promises it to pay it most, right? So the builders, like as I said, like there are different builders. So usually the builders always select the bundle of the transactions who promises it to pay the most. Just the bundle where there will be more value, that particular bundle builder is gonna pick. Okay, cool. Now discuss some builders facts. We will have to discuss that, showed you some diagrams, but these are like some important facts that you should be aware of. Like, so first of all, this diagram is like top 10 block builders by block proposed daily. Like this is Galaxy Research. So these are like builders, top 10 block builders. Their name, they might be unknown, whatever, right? So yeah, this how much profit they make, whatever, right? This is daily, like daily 3 ETH, and this amount goes down. And then yeah, these are like top builders. You can go and search these names, you will get it. Number of block proposed, block with profits, block with subsidy. You can check it out. Okay, some facts about it is like MEV Boost will select the block that pays the most to the validator. Like searching building is also like a highly specialized and competitive marketplace. As I said, like the order flow represents the bigger advantage that builders have over each other, right? And if a builder has access to the bundle that other builder doesn't, right? And if those bundles contains more MEV than what competing builders have access to, a builder will be able to submit a higher value block to the validators and land on chain more often. So if suppose if a builder has more access to that particular bundle that has more value, then there are higher chances that his block is gonna get submitted. Like, so yeah, MEV Boost always selects the most pays the most always selects the block that pays most to the validator. So after this process, like this is like after the builders have built the block, the MEV Boost will always select the block that pays the most to the validator. So most profitable block will be already be selected. Okay, so so every searcher does not does not trust every builder due to the potential for MEV stealing. So I talked about this in the previous slide. Like, searchers do not submit their bundles to every builder available, right? Which differentiates like the order flow between builders, right? While it may seem that the optimal strategy for them, like for the searchers to send their bundles to every builder, right? But that is not the case. Like, to maximize the chance of being included in the next block, right? This does not really happen practically, right? Every searcher does not trust every builder due to potential for MEV stealing, right? And some builders charge a fee for their services, which might affect the profitability of a specific strategy, such that they prefer not to send bundles to such builders. In addition, like, sophisticated hardware builder rely on close collaboration with specialized searchers that identify MEV from strategies more complex and profitable than their own. And from the perspective of searchers, like, builder may also front run searchers bundle itself, right? So we have talked about bundle, we have talked about front runs as well, right? So this might happen, like, the searcher, so there are different builders, 1, 2, 3, whatever. So in this diagram you can see there are different builders. So you might think that searcher should always provide his bundle to every builder, right? Just to make sure that his bundle get executed and he may get the profit. But this is not the case. What if he provided bundle to this builder, and this builder is like that, hey, I got this bundle and now I'm going to front run you and actually submit that bundler of my own. I will not give you any profit, right? So this can happen, right? So that's why searchers usually submit transactions to not every builder, only to those who they trust and who they have been working with for a long time. So this may happen, right? So yeah, it's always like, trust reputation as an honest builder is key here, and to facilitate like the close collaboration between specialized builder and independent searchers. So they are like independent searchers, so they have like close relationship with these builders, and yeah, this is like very important, right? And sometimes like people who are searcher and who are builder are like same entity. This also happens. Okay. The new builders can only really break into the less market initially operating loss through block subsidies. Less like this means that searchers will send their bundles to the block builders who are historically like most successful at lending their blocks on chain, right? So this can be the same. Like, searcher will only they will check the reputation of the builder. Like, hey, if this is historically most successful lending their block on chain, then why not choose that builder over other builder, right? So this can be happen. So these searchers do not send bundles to less successful builders unless they're certain that bundles will not get stolen or get front run or get censored. This trust is very defensible mode for incumbents. New builders can really break into the market by actually initially running at a loss, and by paying above the value to the block to win the PBS auction, or by paying for exclusive order flow. Does it like to make sure that their identity or their image in the particular ecosystem is good? Then only builders, the searchers are gonna trust it, right? So here also you have to make your image and run at a loss in first, and then only you can enter into that market. Okay, cool. The other one is, if the builder were to continue stealing bundles, eventually enough searchers will stop using it. Yes, so searcher whose bundle was stolen. So if that, it can be a case like if there is a builder who stores the MEV the bundle of the particular searcher, then a different interest from the executed bundle. If the bundle is executed from different address from the executed, that who executed the bundle, right? After this, like, searchers who use MEV was stolen, like, they would stop using that builder. So if you are a builder and I'm a searcher, if you front run my bundle, or if you stole my bundle, I will not be able to I will not do that I will not again provide work with you, right? So we will stop using that. Now, if this builder were to continue stealing bundles, will eventually enough searchers would stop using it. Like, if you do it once and if you do it again and again, then there is a group, searchers basically talk to each other, right? So they have different groups, they have different Discord servers, you can join them, right? So they usually talk, and if they talk and they realize that, hey, this block builder is stealing MEV, so they will discuss and they will blacklist the builder and they will not use that, right? So this is because it would be building blocks from such smaller selection of bundles than other builders, like, which limits to likelihood that it constructs the most valuable block available. Searchers, they talk to each other, as I said, on these groups, and they will get to know if search builders, continue stealing the blocks, right? So yeah, these are some facts and some in-depth things about builder. Okay, so yeah, I hope that is very clear. It's not a piece of a cake here. You can also become a builder now. I hope you get things sorted now. Now let's move to other component, that is relay. But before moving to relay, let's go back again to the diagram. Yeah, so step 3 here is step 2 and 3. Searcher is submitted to the builder. Now builder is he has created the block. So we are here. Builder has created the block. So we are here. Now what is going to happen in step 4? Relay and proposer. Let's solve this mystery as well. Okay, cool. So what is a relayer? Okay. But before discussing actually relayer, so before Flashbots, the only stakeholders in the ecosystem were searchers and the miners, mining pools, right? So there were the searchers in the mining pool. Now after MEV Get was released, the relays were added to the MEV extraction supply chain as like trustless communication channel between the miners and the searchers. Like it was a communication channel, and the move to proof of stake, like the merge, brought it fears of sophisticated staking providers causing like consensus level centralization. And to address this, like after the merge, Flashbots created this MEV Boost, right, to separate the roles of block proposer and block builders, to increase specialization and to avoid centralization. As I said, like till the moment the PBS, the enshrined PBS is being worked upon, there was centralization issue. That's why MEV Boost came into existence, and they introduced this like about a decent centralization at consensus level. So it's like temporary solution. Okay, so as a background, like we already discussed, like relays are off-chain marketplaces where builders basically participate to in a blind auction to sell their block to a validator. Okay, so that their block could be proposed on chain. So originators like generate these transactions in this diagram, right? There are there are searchers who user and searchers, they are like the originators. So they generate the transactions. The mempool propagate transactions, right? So there is like the mempool public and the private mempool. So they propagate the transaction. Okay. After that, like the block builder that we discussed, build a block maximizing the prosper fee. Again, this is like same diagram. The block builder is basically building a block that is maximizing the prosper fee. After that, relay that we are discussing, relays act as a trusted auction house, and the structured auction house between all these blocks are here, right? And then after that, the proposer selects and signs the winning block. In the figure, like block C, as you can see in the block C, was the winning block because it bits the highest proposer fee. You can see like there's 0.2, 0.2, 0.1, then 0.5. So in the relay, the block C wins because the proposer fee, highest proposer fee is 0.5 in the block third. Okay, block C, right? And the relay auctions like hold every block where block builders participate with their bits. Like, so relay is basically holds an auctions, right? Holds an auctions where the block builders participate with their bids, right? And the block builders which proposes the highest bid wins the block, like wins the auction, right? Simple. Cool. Let's move on to our next slide. Okay. Diving deeper into the competitive dynamics of builders, it is important to consider the fact that several builders like Flashbots also operate their own MEV relays. Okay. Despite there being little to no financial incentives for businesses to run their own relay, the number of relay operators were only grown since switch to POS. So before POS, there were very less relays, but after that, like they have seen growth into this relays, right? And the motivation for running a relay is basically like there is no as such. Most of the people who run relay are like, hey, let's do it for the betterment of the Ethereum or for the protocol, for the whole system health, right? And there's no like as such profit to become a relayer, right? And the cost of running relay is also a little high. That's why, you know, this can be the scene. And like centralization is a very important thing with relays, right? So let me actually show you. There was a good block with which was the MEV book, like what are the problems and like what are the things with the relays. Let me just search it, or maybe we can just discuss it later. Okay, I will just provide the link to that blog in the description of this video, so you can check it out. As we have already discussed, again, like the block builders A, block builder B, block builder C, you know, we build best block possible with available transactions. They build a black blocks, and there are multiple relays. Relay 1, yet another relay, and then the relay picks the best from the connected builders, and then most profitable block is picked best from the MEV Boost, as we already discussed, and the most profitable block get to the validator, and this they run, right? So yeah, relay. Relayers. So some facts basically. So some relayers censor all blocks containing US sanctioned address, right? So, so as I said, like there is multiple relays, right? So you can go to this MEV relay list. You can just Google MEV relay list, and there are like MEV relay list, multiple MEV relays. You can check out, and they have different things like filtering and consensus. So sometimes some block have filtering, they have some censorship, some relays, right? So there are only few relays operators that actually supply the vast majority of blocks on Ethereum, right? The problem surrounding relay centralization is like already created issued with like censorship, because you know some relays censor the blocks containing US sanctioned addresses, because there are validators who want to avoid any potential legal ramifications of adding blocks with sanctioned transactions. So it's like blacklisted address by the US government. So, you know, as a block builder, as a proposer, I don't want to get in trouble, right? So that's why, you know, you sometimes some relay sanction and, there are some censorship, right? And ensuring there is centralization and ensuring neutrality with regards to regulation is very important, like for Ethereum, which means that removing this vector of censorship is the key. Like you don't want this censorship in the ecosystem, like this is bad for this is not decentralized. We don't want censorship, right? So this is some relayers, they block some US sanction addresses, right? So yeah, and then relays are currently like brokers of trust between the validators and the builders. Yes, so like in fact, like the original PBS specification did not include an external relay role. Like this is important. Like the original PBS specification did not include an external relay role. The current plan by the Ethereum Foundation, which is to enshrine PBS in protocol, involves the creation of neutral in protocol for Ethereum. Like because relays are currently the brokers of trust between the builders and the validators, and protocol solution will need to assure that both the parties, like the builders, will not have their MEV stolen to the proposer, right? We discussed it now, and the proposers will get the payment that was promised in the block header, right? So this is like two in protocol solution that will need to assure like both parties, right? And we will actually talk about one issue that happened with relay right after this, like which was very interesting. Like if you are still watching this course, then you will be interested in the MEV ecosystem. And there was like recent hack that happened with the out of the protocol PBS implementation, that is with PBS Boost. That was interesting. So we will discuss it after this. So now moving on to the block proposer. After that, we have one more slide where we discuss the relationship between the validator and the relay, like what actually is technically what actually is happening. Okay, so but before that, it is important to understand block proposer or the validator part. Okay, so moving back to our diagram, as I promised. Okay, so now your searcher has submitted transaction bundles to the builder has created a block. We've discussed all the things, the facts, the technicalities. After that, there is a relay. We have discussed relay. The most profitable block is selected and it goes to the proposer. Now, this process left, like how the relay is, proposes block to the proposer and what's the job of the proposer. Okay. So now let's discuss block proposer or validators. What is happening? The next step. Okay. So as block proposer is a validator basically who's responsible for submitting valid blocks to the Ethereum blockchain. Like on Ethereum, a validator can be chosen to be a block producer if they've staked like 32 ETH to deposit contract. Like you can become a validator, and validator gets randomly selected by Ethereum consensus mechanism, and in return to become basically block proposer, and in return for this work and for committing their stake to slashed, if they misbehave, they can get slashed. Okay, and they receive a block reward as well. And these block proposers are like the final step before the MEV extracting blocks are submitted to the blockchain. And this block proposers, as I said, like receives different proposals for blocks from block builders via third parties relays that we just discussed, and with an associated bribe to the block proposer. Like there's always bribe included. That's how like the proposer is gonna select the block, right, over other blocks. Okay, and actually the proposer only receives so-called execution payload header. Now, very, very important thing to discuss, like to focus on. Listen to me very carefully. Okay, so as a proposer, this is proposal, this is block builder. You don't get, like the validator, the block proposer, the validator doesn't get all the block content from the block builder, right? It only receives execution payload header. When I say block content, it means all the transaction list, whatever in that block. The block builder doesn't pass all the things to the validators. It only receives so-called execution payload headers from the relay, right? This contains like enough information basically to reliably evaluate the value of the block, but not to execute it, because it does not have the transaction content, right? And this means that a proposer cannot just steal the MEV by submitting the block provided without paying the searcher, right? So if suppose one of the case would be like if the builder is providing the whole block to the validator through relay, then this validator may run away and he may front run the builder, and he may took the block and he's like, oh, I will not pay you. I have a block. I will just propose it on chain and I will get the price. Why do I have to pay you and then searchers and whatever? I will just front run it. That's why there is only like execution payload header that is only received to the proposer, and the contents of the block are only revealed after the validator has committed to the payload header, after which it can be proposed as the next block. Okay, so this is the case. Like the validator is only receiving the execution payload header, right, from the block builder. The validator is not receiving every content from the everything out of the block builder. Okay, and execution payload header is like I've actually gone to the codebase of MEV Boost. I will share you the link in the description. So this is what execution payload header is. Parent hash, what does it include? Coinbase, state root, receipt root, log hash, block number, you guess, use timestamp, whatever, right? So this is like the execution payload header that MEV Boost tool uses. Okay. Yeah. So if you are interested in codebase, I will provide you link in the description. Validator and relay, again discussing the relationship between validator and relay. Why I'm discussing this, because I want to showcase you one example after the slide. So between the start and the end of the block auction, like the block builder delivers the block contents and block bits to the relay. A block auction basically lasts like 12 seconds in MEV Boost, in MEV Boost, and in above figure, like basically this symbol, like the lightning symbol, represents like bits by the block builder. Okay, so the relay simulates the block contents to ensure that it's valid and that the proposer receives the fees from the block builder. After the simulation, the bid becomes active in the block auction. Okay, so now you must be thinking like, so if there is like if the block builder is, this is like what I thought, like if the block builder is only providing block header to this validator, how will they make sure that the block is actually valid? What if there is a malicious transaction in that? What if there is like a wrong transaction in that? Because he is the one proposing the block, no? So he will get slashed if there is something bad in that block, right? So what will happen is that this relay make sure, it ensures that the block proposer, that the block actually, a proper block, and it simulates the block contents to ensure that it is valid. And also it also just simulates that the proposer receives the fees. Okay. After that, like at the end of the block auction, the proposer requests the block header, right? The proposer, the end of the auction, once the auction is completed, the block header, the proposer basically requests the block header. Okay. And once that is completed, like the block header with the highest bid, right? If the relay share all the block content, then a rock proposer can steal the MEV again. If the relay shares all the content, then this block proposer can run with that, right? So a relay can also steal this data. Hence the relays need to be trusted by block builder. So relay in between. So if there is a centralized relay, then this relay can also steal the MEV, right? So it's a very big problem. Okay. Right. So they can also, they should also be trusted by the block builder, right? So yeah, this can also be the case. So if several relays are connected to the proposer, right, the proposer chooses the block header with the highest bid and sends the signed block header back to the relay. Okay. So highest bid, and then what the block proposer do is it basically signs the block header back to the relay, right? And then the relay verifies the signature and then shares the block content to the basically shares the block content to the block proposer. Okay. And already also broadcasting the block over the P2P layer. Okay. Yeah. So this is like the simple validator and relayer relationship. This is how it works. Now, this is like, there was one very interesting case that happened, and it was like very concerning for the whole Ethereum community, and I liked that case. Now what happened? Let's discuss that. Okay. So on 3rd of April 2023, MEV Boost relay incident and related timing issue happened. This is like the post-mortem report, right? This is also known as like Sandwich the Riper attack. If I'm not wrong, just Google it, Sandwich the Riper attack. Okay. So even this was not enough to fully protect the MEV stealing. It just made it extremely actually rare. So a vulnerability in the Flashbots relay made it possible for a block proposer to submit an invalid block header, which allowed to steal $20 million from a searchers without having to outrage the relay, right? So there was a bug. Basically, there was like, so there was this vulnerability in the MEV relay, this relay that allowed the block proposer to, to gain a profit. And how that happened is that, so the MEV Boost works through a commit and reveal scheme where the proposer commits to a block created by builders. We just discussed that without seeing their content by signing the block header. And only after the block header is signed, the block body, the corresponding transactions is revealed. And the attack on the April 3rd was possible because the exploited relay revealed block bodies to the proposer as so long as the proposer correctly signed the block. But however, the relay did not check if the block header was signed that was invalid, right? The relay would attempt to publish the block to become the beacon chain, where beacon chain nodes were rejected. Crucially, regardless of whether the block was rejected, the relay would still reveal the body to the proposer. Okay. So now what happened? Let's into this diagram. So I just showed you like how this works, right? So block the whole body content is not revealed. Only the the block header is revealed, right? And then the block proposer has to sign that block header. and then the whole block content is received. But what happened was that, so this relay, there was a bug in this. So they asked the block proposer, they sent basically the executed header, and then block proposer was also malicious. What he did was, he signed the block incorrectly, right? And the signature was not valid. Okay, but so he delivered a wrong valid non-valid basically signature to the relay. So but relay was not aware of that. So what relay did was, relay submitted the transaction to the basically to the beacon chain, right? So the beacon chain, when the block was submitted to the beacon chain rejected it. Beacon chain rejected it by saying that the block is not valid, the signature is not valid. But during that, the relay had submitted the block, like has revealed the block content to the block proposer. But and in this case, the block proposer received all the block content from the from the relayer, and having access to the block body, he was allowed the malicious proposer extracted the transaction from the stolen block and used them in his own block, where he could exploit those transactions. So he was able to see all those content. He was revealed all the content, and he was able to create his own block, and extracted the MEV, and dissed everyone, just made the profit. And yeah, this happened in this was like very interesting. And yeah, and after that there was a solution as well. So the solution that was introduced for this was that there will be like a cutoff timing into the proposer slot, where this time, like 3 seconds, that after this 3 seconds, the relay will no longer return block to the proposer, right? So there was like a cutoff timing. Earlier it was 2 seconds, but after that it was moved to 3 seconds after the valid, like the nice proposer validator requested for that, because 2 seconds was very less time for that. So there is like a cutoff timing for 3 seconds. After that, the relay will no longer return a block to the proposer. Simple. Yeah, so coming back to our presentation, so this was like very interesting thing that happened. You can actually go and check out this post-mortem report. I will provide the link in the description. Cool. Now, I guess this completes our MEV Boost architecture, and we have successfully seen the architecture of the MEV Boost and the PBS. So congratulations. Okay. Oh, this is funny. So we have already discussed searchers, builders, relay, and proposal. We have discussed everything in deep, how to become a searcher, what builders do, relays, proposer. We have discussed the post-mortem report as well. Nobody is gonna discuss this, then I'm pretty sure like this is like one of the best content that you ever get. Okay. Now moving forward to our course, few things are left, only 2 topics that are left, and after that we will jump on to coding part. Cool. So MEV products, CowSwap, Fastlane, Colibro. So there are definitely there are a lot of MEV products that are available in the market that you should check out. Some of the products are like CowSwap. So what is CowSwap? So CowSwap is like, you can check in the diagram. So basically CowSwap tries to settle buy and sell orders between its users, like basically finding coincidence of wants, right? So there, you wants to do the transaction, you wants to do buy, and there is another one who wants to sell. So they, the CowSwap basically connects you two guys, which also prevents slippage and fees. An order that actually fails to find a peer that are sent to CowSwap under AMMs, normal AMMs that are sent to CowSwaps underlying all the automated market makers. After that, like MEV, after that there is Fastlane. So Fastlane is like MEV relays to safeguard users and deliver superior results for high frequency traders. It is on Polygon. You can check out that. After that, Colibro is like the first BEV layer, the broadcaster extractable value that allows transaction broadcaster like node providers, non-custodial wallets, and bridges to improve user experience, right, and enable MEV ownership. That is one of the first BV relay, Colibro, that you can check out. Then there is MEV blocker, just like Flashbots provides free RPC. MEV blocker also provides free RPC endpoint that protects user from fast running and sandwiching, which we will see a live example in the coding part. After that, there is Jito. Yeah, Jito was very actually famous these days when I'm creating this video. Jito Labs is like a leading Solana MEV infrastructure. They did a massive airdrop, which was really cool. So they built a high performance system to basically maximize performance of the Solana blockchain. In this particular course, we have discussed Ethereum. So, there was no discussion of Solana. But yeah, if you want to discuss, like, the thing is with Solana is that there are very differences between the architecture, because the timing for block timing is very fast in Solana. It was 12 seconds here, and it was very, very fast. I don't exactly know the timing of Solana block. So yeah, but this is very fast in that. Most probably 1 second or 2 seconds or even less than that. You can just Google it. Yeah, so this is like the architecture is very different. So yeah, you can go and check out Jito if you're a Solana developer and if you want to focus on Solana ecosystem. Cool. And also Avalanche is also there, and there are different blockchains, but I want to focus on Ethereum as of now, but you can check it out. There are also some blockchains that are claiming to build a MEV resistant blockchain. I don't know how they're doing it, but they're doing it. So you can check that out as well. SUAVE and PEPC. What is PEPC? PEPC is not that Pepsi that you drink. So basically, PEPC is protocol enforced proposer commitment, right? Story only now only header is revealed and not content. Like, however, if so basically, as we discussed, right, that only the header is revealed and not the content. However, like, if the additional slashing rules were imposed on the validators, right, through EigenLayer for front-running builders, there is a stronger guarantee that a builder proportion of the blocks get included correctly at the beginning of the block or otherwise than restrict validator, right? So EigenLayer is like this new protocol that would act as like the middleware. Eigen is like very famous protocol, but is a middleware software that was facilitate the bidding process between a building and validator for the partial block space. And like, this is very, very important capability that would eliminate the concern around the relay censorship and ensure the censorship resistant and quality of the Ethereum and enforced by giving back the ability of validators to, also propose a transaction for the inclusion in the block. So we already discussed it as of now, right? So that the builder only gets does not get the content of the block, right? So he is not able to include transaction into that. But the EigenLayer is like a restaking tool, whatever you can call it, like restaking protocol. So that they introduced a solution that they will be like additional slashing rules that will be applied to block proposer, that if they try to front run the block that was provided by the block builder, they will be slashed. So yeah, so this is like proposer by EigenLayer. So yeah, there will be like extra space available. Like there will be a builder part, there will be like proposer part as well. So proposer can also add transactions to the block. So this is like more decentralized way and more censorship resistant solution that they provided, like PEPC, that was by EigenLayer. Okay, there is a good presentation by Sriram. He's the co-founder of EigenLayer. So there is a good presentation by him. So you can go and check out. Just Google YouTube, search on YouTube like Sriram, SUAVE or PEPC, whatever, EigenLayer. It's a good presentation. Okay, the other solution is SUAVE. So what is SUAVE? SUAVE is a single unifying auction for value expression. In theory, like SUAVE will be a blockchain. Basically, it is introduced by Flashbots. First of all, it's also a solution by Flashbots. So SUAVE will be a blockchain that is able to accept expression of user preferences from like multiple blockchains, and not just Ethereum. They're talking about multiple blockchains, and then assist basically a decentralized networks of block builders to trustlessly propose blocks to each of these networks. Like the SUAVE chain will be composed of basically 3 main components: the universal interface environment, okay, and then the universal interface environment, and the other one was an optimal execution market, and the third one was the decentralized block building network, right? So yeah, so there was different roles, and Also the problem right now is that not much detail is revealed by SUAVE. It is still in progress, and not as of now, when I've researched it, not much detail is provided. So it is very secretive, and more information will be coming out soon. But yeah, this is like the product that you should keep an eye on, because yeah, Flashbots have been doing amazing work, and they have been saying that SUAVE is the future of MEV. So definitely check it out, SUAVE, and what they are trying to do. And whenever the information is available, I will create a proper video, and I will also share it on Twitter and LinkedIn. So if you're not connected with me on Twitter and LinkedIn, go and just follow me there. I will just provide the things or update there. Okay, cool. So I guess this completes our theory part. But before moving on to the theory, I'm gonna tell you more about the opportunities in this space. I want you guys to be create career in this MEV space or whatever. I hope so that this video was helpful for you guys. And opportunities are like contribute to these open source projects. MEV Boost, Ethereum is open source. MEV Geth, whatever client you can contribute to that, they are all open source. MEV Boost is open source. Go and contribute to these projects. Join their Discord. Ask for good first issues if you are a beginner. After that, there is a PBS Foundation grant program that recently is introduced, and they're like Consensus, Coinbase, they've joined together to form this PBS Foundation. So there is a grant program. Go and apply for a grant there. Actually, let me share my screen to show that to you guys. Cool. I hope you're able to see my screen. So this is like a PBS foundation that was introduced as of now, right? So yeah, mission and goals, what is PBS separation, and then there is grant infrastructure grants, research grants, data transparency, community education, whatever. You can fill out this form and you can check that out. Okay, cool. Contribute to research, like contribute to researches. Go and check it out. There is MEV Research Fellowship Program by Flashbots. Go and apply to that. Contribute to the researches, whatever research. Everything is open source. Everything is there, as already showed you. Like proposers are already there on ethresearch.th, whatever this website is. You can go and participate and talk to people, talk to professors, whatever. Hack and Eat Global, Flashbots, MEV hackathons. They organize hackathons. Participate in that if you are a builder. Join the community call. As I said, PBS is open source. They want people to join the community call. Go and join that community call. Understand more about it. Understand opportunities. How you can contribute. Then after that, you can become a searcher. You can become a builder. I've explained to you how to become a searcher, builder. I've also showed you actually the tools that were used. REVM, I've showed you the Mempool, whatever. I've showed you like Block Native API, right? So yeah, Block Native, search Block Native, and then you will get to see a API that you can use as a searcher. Then builder, and then all of these companies are hiring, right? So all these companies are also hiring. Flashbots, the Jito, whatever we discussed, the companies, Fastlane, and then whatever companies we discussed, they're all hiring. So if you are like an MEV expert after this crash course, I guess you will be an MEV expert. So go and find a job and ask if you can be their researcher or community manager, whatever, dude. And then build your own MEV products. So as I said, MEV is basically a multi-billion-dollar market, right? So let's move on to the next slide. MEV is a $1 billion market. So go and build your own products. You can check that out. And, it's a big market. There are a lot of opportunities there. And recently there was the Jito airdrop. So you can, just follow what are the things that are coming there, what are the research that are going on, and you can go and contribute to that, build your own MEV products. It is a big market. So yeah, go ahead and do it. Now let's move forward. Hope that opportunities were clear. I will provide the link to all of those in the description. Now let's move forward to the live MEV, where I will get myself front run. I will show you how the MEV works, and I might do it on L2 because Ethereum will be very expensive. I don't want to pay that much fees. I'm not that much rich. Okay, so let's move on to our live MEV. We will also try to create a MEV bot, and let's see how it goes. Let's see how the coding part is, and you will understand more in-depth things. So yeah, let's move forward. Okay, so now I am right now on Remix IDE, and I've created a code that is a simple front run me contract. You will be able to find this code in the description of the video. I will provide a GitHub link to that, but it's just a very simple smart contract that we have written so that we can make sure that so I want to show you guys an example where our code, basically our contract, whatever we are trying to do, our transaction will get front run. And in the second one, in the second try, we will be using Flashbot RPC. So when we will be using Flashbot RPC, our transaction will not get front run. Okay. So right now, this is the simple code. Let me just simply go over that. Okay. So the contract name is contract front run me. Then there is a mapping that connects the address to the bytes 32, which we will explain what is that. Okay. So there are two functions in this particular contract. It's a very simple contract. One is deposit. So anybody can deposit into this contract, okay, by providing a secret code that we will be providing, and then there will be a mapping that will connect that secret code to the particular address, whoever is calling that deposit function. And then there will be a withdraw function. In the withdraw function, whenever that user, so anybody can call that withdraw function and pass on the address and the secret code. So if so it doesn't mean that only the owner can call this function. Anybody can call this, and if you just need to pass on the address which you used while depositing and the secret code, right? So anybody who knows that secret code, maybe the person who deposited, they have other than that person also, someone else can call this withdraw function. Okay. And yeah, if that is not the correct one, then it will return wrong password. It's just simple as that. And then this function just this line just directly sends all the contract balances to the caller. Okay. Yeah, just a simple smart contract. Okay. Now let's see how this works. I have tested it on the testnet. It works properly, but on the testnet, I didn't got front-end by anyone because I don't think so there were bots and that was enough money for them. But now I'm doing it on Polygon mainnet. So yeah, Ethereum mainnet was very expensive. So I'm trying to do it on Polygon POS mainnet. So let's see how it goes. Let's just directly I've connected my MetaMask here. I have like 30 Matic as of now. So 30 Matic right now is around $30. So let's see if that is enough for the bot to front run. So let me just directly deploy my smart contract on the mainnet, and yeah, it's a little slow. Okay, I will have to confirm the transaction. Okay, so hopefully this contract should get deployed soon. Okay, so our contract had been successfully deployed. It took some time. Now let's interact with our smart contract. So there are three functions as usual, two functions actually, then the deposit and then the withdraw, and then just this I guess the mapping. Okay, cool. So the deposit function, we need to deposit some Matic first of all. Okay, so now let's call the deposit function. So for that, I will pass on the value from here directly. So let's do it like 20 Matic. It is around $20 as of now. The price of dollar is around price of Matic is around $1. Okay. So we are passing 20 Matics, so I hope it will be enough for the bot to front run us. So now we have to pass a password. So for that, I'm gonna use the Foundry cast Kechak function in my terminal. I don't think so you will be able to see it. So the password is just 1234. So I have just hashed it, and I'm gonna pass that in that function. Okay. So I'm gonna call the deposit function now, and hopefully our transaction will be submitted, and yeah, our 20 matic will be deposited to this contract. Okay, and success, if it is submitted successfully, the balance should update to 20 ETH. So our balance has been updated to 20 ETH. That means that this contract contains 20 matic, which we just deposited right now with our secret password. So now to withdraw this, I'm gonna call the withdraw function. Okay, and I will pass on the address, and I will also pass on the correct secret code. Now, hopefully, our transaction will get front run by a bot if $20 are enough for them. Okay. So, and I'm right now using like MetaMask's, initial RPC URL, which is Infura, if I'm not wrong. Okay. I'm not using the Flashbots RPC, which will help us to, save us from front run. Okay. So let's see if our transaction gets front run or not. Okay, so I'm gonna just copy my address from here, and I'm gonna again copy my the password that we put it on while depositing. Okay, so I've provided both of them. Now I'm gonna call the function, and let's see if we get front run or not. Cool. Let me just sign the transaction, confirm it, and let's see if the balance is updated to 30 ether, then I guess we will be successfully, we got our token. But if not, then we definitely got front run. So the function has been successfully called. Now you can see here that the withdraw function was successfully succeeded. Okay, and it has been called, but and you can see here that the balance of the deployed contract is 0 now, which means that the $20 was when I called the withdraw function, right, I didn't get those 20 ether back. Why? Because someone, maybe a MEV bot, front run me. So now let's actually go to Polygon scan to check out what really happened with our contract and how it got front run. So let's go to like Polygon scan. Now it's Polygon scan. We have to do it on mainnet. Cool. So on the Polygon scan, just paste the contract address which we deployed. Okay, so now you can check actually what happened. Okay, so let's go line by line and see what happened. Okay, let me just make myself small. I think I'm pretty big here. Okay, yeah. So the first transaction was that the contract creation one, we created the contract. The second one was that we called the deposit function, and we deposited 20 matic. And after that, we tried to call the withdraw function, but what really happened? We tried to call the withdraw function, but the value here is 0, which means that the transaction was successful, but there was literally nothing inside the contract. The contract balance was 0. That's why there was no transfer of 20 matic back to us, right? Back to the or back to us, right? So now you go, if you go to the internal transaction, you will check that there is an internal transaction, which means that contract called our contract itself by passing MEV. So what exactly was happening was, so let's actually go to this transaction, and let's go to this contract. So if you see here, this is a contract. So this is basically a bot that is running on the Polygon chain, which called our contract like withdraw function before us by passing the secret hash, which we decided, because which we passed on, right? So so the bot actually saw that here we passed the contract, we called the withdraw function with that particular hash, right? And here they simulated the transaction, and after that the bot saw that this is a beneficial transaction for them. They can generate $20 value with that. So they basically called our contract. So as you can see here, like this is basically the EOA. So inside the bot there must be a private key. So the private key is of this public address. right? And then this is the bot that called our contract. Here so you can see like 20 transferred metric from our contract. This is our contract address to this contract address, right? So this is simply what happened. And one more thing to notice here is that if we go back to the transaction, okay, so this is our withdraw function, right? So this is the withdraw function that we call, right? So here the gas price is, you can see 43 kwe, simply you can see, right? And if you go to the internal transactions where bot called, so what he did was, what the MEV bot did, he called it with a better gas price, right? So that's why, his transaction was successful before us, right? Right? So basically this means that they front run our transaction. Okay, so yeah, this is simple as that, and we lost $20 to MEV bot. Okay, so this is the basically the timeline of how things were working, and this is on mainnet. So I hope you now have an idea of how a transaction could get front run. Now, if you are a beginner or something, then you might want to understand what's happening here, what is transaction hash, what block number, transaction from to. But if you already know this, like you can see the transaction fees as well. The internal transaction is basically when a contract calls another contract. Okay, and yeah, and if you even want to see, so one thing would be like you must want to be like that, let's go to the contract, the MEV bot contract, and let's see their code, right? But the contract is not verified, right? So you can't really you can't really see their code base, and that's pretty simple, like why, because nobody who actually is running a bot on the mainnet will never reveal their bot code, right? And even if online, if you are trying to search an MEV bot or something, that probably it means that someone has that it's not really working anymore now, because nobody really reveals their working bot, right? So that's why it's not really verified here. Although you can use this bytecode to decompile this bytecode, you can copy this, and there are various tools available, but most probably like 99% it will not be decompiled properly. There will be some maybe this code is also written in assembly or something, right? So this will not be decompiled properly. So yeah, it's not verified, so you can't really see this. Okay, so let's go back to our code now. I hope you understand. I will, if you want, I can provide this scan transaction link in the description, or maybe you can just copy this transaction code, whatever. Okay, now let's go back to the to our remix. Now what we will do is, the next thing would be that now we will do the same thing, but after deploying the contract, when we call the withdraw function, we will call it through a Flashbot RPC. So it's like a MEV blocker. So in this, our transaction goes to like a private mempool where the bots are not really scanning all the transactions, right? And it will automatically it is gonna get successful. Okay, so you go to the, maybe just type it on the Google, like Polygon MEV RPC, and if you go there, you might see somewhere. Okay, yeah, just go to Ethereum stack, and someone must have pasted it. Okay, so this is the RPC endpoint, the Flashbot RPC endpoint for Polygon. Okay, so just copy it and then go to your MetaMask, and after going to your MetaMask, go to settings and just change the RPC. Wait a minute, network, we are on Polygon mainnet. Okay, now here just change the RPC to Flashbot. Could not fetch in. Is this RPC correct? Yes. So I just found out that the Flashbot RPC doesn't support Polygon. Most of, like, I went to their documentation, and their RPC URL is only for the Ethereum mainnet. Okay, so maybe Polygon is not supported, but I found BlockPy network that is like distributed RPC that is also MEV protected according to them. There was something that I found out, and now let's actually go and use this RPC to check if our our transaction gets front run or not, or is this RPC MEV safe or not. Okay, cool. So let's copy this and paste it or in our MetaMask, or from directly here, just click on that MetaMask and just directly approve your transaction. So the Polygon mainnet will be added there. Okay, cool. Yep. So we are on the Polygon mainnet, block mainnet, block PI. Okay, cool. Now let's go to our remix and do the same thing again. So again, I'm gonna just call the deposit function with maybe the same catch-up, right? Okay, so last time I used 1, 2, 3, 4, 5, 6, 7, 8 as my password. I think you will not be able to see my screen because using the terminal, I don't know, the screen has not been shared. Okay, so but I have copy pasted that hash of the password is simply 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and again we will call the deposit function, and this time let's just deposit 9 matic. Okay, I don't have much balance, but I guess 9 balance will also be enough for an MEV bot to calculate that they can front run it. But hopefully, since we are using MEV protected RPC by BlockPy, it will not get front run. Okay, so now let's call the deposit function. Let me pass on the secret hash. Okay, so for calling the deposit function, let me just approve this transaction. Okay, I'm saving like 1 matic for the gas fees in the future. Okay, so the contract, the deposit function has, it was called successfully. Okay, now you can even see the updated balance as 9 matic. It's 9 matic here, not 9 ETH. Okay, and now again we will call the withdraw function and let's see how it goes. Okay, so to here I will just paste that, and let me also just copy my address. So I think it's already there, but yeah, just to be safe aside, let's paste again. Okay, I hope it's the right address. Yep, it's the right address. Okay, so now the exciting thing, we will call the withdraw function, and let's see. Hopefully, since we are on, we are on the Polygon, mainnet by BlockPy. Okay, hopefully we will not get front run, and if we get front run, then it's the problem of their RPC API. Most probably, that's not working because we did everything right. Now let's just call the withdraw function and let's see if we get our 9 ETH back, 9 matic back or not. Let's go. I've called the transact function. The MetaMask is popping up. I'm gonna confirm the transaction. We are on Polygon mainnet by BlockPy, MEV Producted RPC. I've confirmed the transaction. Now let's see. Hopefully we should get 10 matic as our updated balance. Okay, so when I was doing the transaction, I just found out that I never changed the password. I used the same password, which was not a great idea, and I got front run again. And now I'm going to again do the transaction with little less matic, and let's see if this is MEV protected or not. But yeah, I just did a foolish mistake that I used the same password and it got front end again. So right. So now let's again do it with a different password and let's see how it goes. And hopefully it will not get front end. Okay, so we are back to the mix, and now we again have to deposit some ETH, and we have to, again just call the withdraw function, and let's see if we get front run or not, and if this RPC is MEV protected or not. Okay. So this time I've used a different password. Okay, the password is your 123 whatever. This is the hash of that. You can use whatever password you want. Just the main thing is that the password is changed now. Okay, so I'm just gonna deposit 1 ETH. Okay, and yeah, I'm just gonna call the deposit function, and hopefully we are on Polygon mainnet by BlockPy. This is like, according to them, MEV protect RPC. Okay, so 1 ETH has been submitted. Okay, so you can see the balance updated as 1 ETH. Okay, That is one metric. And now let's call the withdraw function. So for that, let me just change the password with the updated one. Okay. And we have to withdraw to like this user is the same one that we because the contract address is same, the US same from MetaMask, which we are calling. Okay. So now let's hit the withdraw function and let's see if we get back this 1 ETH or 1 metric or not. Okay. So I'm clicking the transact, and now let's just confirm the transaction, and now let's see if this was MEV protected or not, or we will lose our $1 as well. Oh, cool. We got our $1 back. Here you can see that 1.51, it was 0.5 before, and I've used a new password. Right. So yeah, I got 1 matic back. Cool. So this means that this RPC is actually MEV protected, and yeah, kudos to BlockPi. Okay, so we have just completely, successfully deployed this contract, and we have seen that how in real life a transaction can get front run, and how we can use these RPCs to save ourselves, this MEV protected RPCs, right? Yeah, this is a really great thing. I hope you understand stuff, and yep. And now what you can do is maybe try yourself. So I hope that you actually understood like what is actually happening under the hood. I showed you like on the polygon scan as well how under the hood things are working. Maybe you can also try to create your own MEV bot. Try to run it and create it on Rust and create it on Python, whatever. I if possible, I can provide you some links in the description so you can check out. But yeah, the motive of this course was not to teach you guys to create how to create a MEV bot, right? And even if like you have to actually understand how EVM works. So if you guys don't know how EVM works, go and watch my last crash course which I created. It was actually my first crash course, which was on EVM. So you have to have a good understanding about EVM, and also you have to write optimized code, mostly in assembly. So whatever bot front run does, that was mostly most probably written in Yule, like in assembly code. So yeah, it's very important to optimize those codes, and yeah. So most of the time is like just reducing the latency and optimizing the code. So these two things are very, very important. Okay, as if you want to write your own MEV bot or something, right? And these bots are on most probably every network, right? Now I was thinking to actually first I was thinking to actually show you guys how to code MEV bot, but I guess there is more there's something that is more important than that. So I'm gonna actually teach you guys and tell you guys about that. Like there is an actual fraud going on right now, especially in the MEV space and MEV bot space. So what exactly is the fraud going? That if you so first of all, like again, like telling you, any searcher or anyone who is gaining profit from that bot, they will never ever share their bot with anyone, even on the internet. Like they will never share it. Like, so if you're getting any bot on the internet and that is saying that, hey, run this bot and you will get $1,000 per day, whatever, right? $1,000 per ETH every day, 1 ETH every day, then that is totally fake. Okay. So there has been a list of for these fraud projects, and like I will provide you the link to this in the description. So there are a lot of fake projects. So what they usually do is, because so they they have a code, smart contract basically, right? I also have this smart contract here, right? So I will explain you what it is doing, right? So just simply they have a smart contract, and then they ask you to run it, and it basically transfers all your ETH to them, right? So eventually you get wrecked, right? And yeah, these are all these repos links. So you have to be safe. And even there are YouTube videos as well. They are doing live streaming. They have good videos. They're doing good marketing that hey, run this MEV bot and you will get money. But this is not the case. Please stay away from this. And now, if you are let's go to the code. Actually, see what's actually happening. Okay. So now, if you are even beginner Solidity dev who understands a little bit of Solidity, will be able to understand that this is a total fraud. Like first thing that to understand is that you can't just create a bot with Solidity script. No, this is not the only thing. This is not the only thing that is required to create a bot. There are several other things that we talked in the video that are required to create a bot, right? So this contract, if somebody's saying you that only run this contract and you will get, MEV, then it is totally wrong, right? This is like the first red flag. And after that, like what is happening is that this contract is actually extremely big, right? So it's like you can see 625 lines. So what they are trying to, make a fool out of you, right? They have 625 lines of code, and maybe this is true, right? So some people will think like that, right? So yeah, so it's a very it's a buggy code. Now what is the bug? So if you just we will not go through each and every line of this, right? So what I've done is I've already deployed this contract, right? So once you deploy this contract, there are 4 functions: start, stop, withdrawal, and order, right? So how does the fraud actually runs out is that they ask you to deploy this contract on the mainnet, and then they ask you to transfer some money to this contract. So they ask you to, hey, copy this address and then transfer some money to it. And after that, after you have transferred money to that, they ask you to run any of these functions, right? So if you even run this start function as well, no, what is gonna actually happen? Okay, so let's go to the start function where it is. Okay, yeah. So if you're gonna call the start function, what it is gonna do is basically it's gonna emit the log that, hey, I'm running front run attack, blah blah, right? But after that, what it is basically gonna do is it is gonna call a function, another function. We will look into it what this function is, and then it is gonna transfer all the balance that is present in your smart contract to their address that will be returned from this function. So everything that you deposited into this contract will be gone. It's simple, and we will go through these functions, but all these functions are gonna do the same. Like if you see the stop function, right? So if you're gonna see stop function here, so see, it is also going to do the same. This just calling another function, just a fake function, and then it is gonna transfer all the balance to that, right? And then withdraw. So if you go to with the withdraw function, it is gonna do the same. Okay, it is gonna do the same thing if you go to the withdrawal function, right? So this is like simple basic math that it's a proper fraud. Now if you go to these these functions, what the inside functions, what they are calling is basically suppose withdrawal profit, right? So just like it is also it is returning an address, right? It is again calling another function, returning it. So they're trying to make it more and more complex, right? And eventually what it is gonna like return is very, very simple, right? So if you see this start exploration function, it is just concatenation. It's gonna concatenate some string and eventually return the scammer's address, right? So this is like fake. Everything is fake, right? This just if you are if you know a little bit of Solidity, even if you know basics of blockchain, then you will understand like what is this, and why do these need numbers and blah blah, and yeah, everything is fake, right? Call mempool length, what is this, and then yeah, everything is a joke. And yeah, so yeah, just wanted to clarify you guys that this fraud is going on, and you will never anybody will never share their proper strategy bot which is actually running on live and which is earning money, right? It is very tough to write those contracts, and nobody will share it to you, right? So be aware of these scams that is going on, right? And it's actually hard to write these MEV bots. And like after this coding part, we have also recorded a podcast with one of MEV searcher where he actually explains that if it is also a big deal if your bot is actually running, right? So code optimization is the second thing, but even if you create a bot that is actually making profit, that is also a big thing, right? So yeah, it's a tough space, it's a competitive space, right? So hope this was helpful, and after this please do watch the podcast that I recorded with an actual searcher, actual builder, who actually explains what is the current MEV landscape, how you can get into it, 2024, what he's bullish on, and yeah. So it's a really good podcast. So you can check that out. You should definitely check this out after this. Yeah, and thank you so much for watching this course again. And if you have any doubts, if you have any questions, just follow me on Twitter and DM me on Twitter. I'm also on LinkedIn. You can check out my LinkedIn. I will provide the link to everything in the description of this video. And if you like this crash course, please comment, let me know how it was, what other videos do you want to see, and just share it with your friends. Just share it on Twitter and LinkedIn. It will be really helpful if you can share it with your friends and, spread knowledge. And I hope this full course will have full. There's also a Telegram group, by the way. You can join there, and I also post a lot of Web3 stuff there, and I also post job opportunities and everything related to Web3 and research as well. So you can join that group as well. Okay. Thank you so much for watching. I hope this was helpful. Please listen to the podcast. Thank you so much and take care. GM everyone, I'm Uttam, and I'm here with Zero X Princess, who has been, really active in this MEV space. So thanks a lot, Zero X Princess, for, joining this and helping us to understand more about MEV. And, in this crash course, your session would be really helpful. So, welcome, and go ahead and, maybe introduce yourself and share your journey, how you got into this MEV and crypto space.
Yeah, thanks. Thanks for inviting me to this podcast and your session. So we were actually MEV searching since 2020. We are our team is doing arbitrage on Ethereum, and we have started long before PBS came out and Flashbots became popular, and actually the Flashbots are introduced all the PBS and the MEV term in particular, and back then everything was called just arbitrage, and just we were just running bots without knowing it would be called MEV. And yeah, and so since Flashbots have started, I think all of the operations got drastically less complex and risky, because before you had to send your transactions right to the mempool or transaction pool, as you wish, and so and you would just, if your transaction didn't land, you would actually see it reverting, and you would be paying for its fees. And because of the high competition in this space, because there were a lot at start liquidation bots, then arbitrage bots, and also sandwich bots, there was a huge competition in this space, and a lot of back then you would see half of the block, up to half of a block of just bots reverting their transactions, especially at the top of the block. And so that's why Flashbots came out and said, look, we are wasting half of the block space for just reverse transactions, and we are making it very hard for just normal people to transact on Ethereum. And so let's make we would not like to eliminate all this competition and just make it's impossible to do arbitrage liquidations, etc. But let's make it a separate environment. And they started this. It wasn't PBS at first, so it was back in the proof of work era. But since PBS, it became really popular and commoditized. So it became widely accepted as a norm in the search space. So everyone are so there's before the PBS, I think there would still be a lot of searchers and bots sending their transactions to the mempool, but especially long tail ones. But I think now 99% of all MEV related transactions are being sent to the Flashbots, and it became so popular that this practice of having such environments became widespread to other chains as well. So we can see other not I would not say like Flashbots copycats, but other projects that are trying to make environments for auctions for the block space. So you have and they're like integrating order flow and the block space from the validator side into the one environment. So there's a Polygon fast lane, for example, on Polygon. I think yeah, you know that, and that's like a great auction with a very different design than Flashbots, and it actually much more constrained, and it's better in a sense that it doesn't allow sandwiches to occur. Yeah, and it's like very it's great in this case. So there's also wall chain on many networks. I think live. It's not really a block space auction, but it's an order flow auction that's also very similar. It just integrates with the apps, right in their UI, and it connects like users directly to searchers. But yeah, and there's also Bloxroute, who's operating on BSC. They're building blocks in the same manner as Flashbots are doing on Ethereum. And yeah, and their auction is very, very similar. It's, I think, Flashbots compatible totally. And yeah, so we see the rise of these kind of environments since Flashbots have popularized and like got adopted by the industry. Yeah.
Got it. Okay, awesome. So can you also just go deep dive into your working day to day? What do you work on? What are you working on currently? Do you have a team, or if you can share that?
Yeah, so we are working like we are making arbitrage bots. So we have like only one strategy. So there's because there's a huge piece called MEV, and we can like separate it for multiple like pieces, and the largest piece is stat arbitrage that connects CFI and DeFi. So yeah, and then there comes sandwiches. That's called hostile MEV. So the sandwich, because it actually makes users execution worse. Because it sandwiches the user's transaction and affects user's execution price. So and then there's backrun arbitrage. So when you are placing a transaction behind the user's rate, so users trading on some pools, AMM pools usually, or it creates some order in the order book. And your backrun, and this order makes it affects the price in these pools that users is using, but it often, very often, other pools remain unaffected, and you can it basically creates an arbitrage window, so you can place your own transaction to balance the price in these pools. Yeah, and that's not hostile. That's actually very good like thing in the space, because it makes price in all dexes the same basically, and it balances it. So other users that will be trading on these tokens will not have to compare all these prices in all different dexes to see which price is better. They can just come to any liquid to any dex with liquid pools and just do their trades without worrying about the price. Yeah, and so that was what we're actually doing. It's I think, and so the competition for these pieces is very, it pretty much correlates with their like market share. So the larger the piece, the more competitive it is. Mm-hmm. And so the background arbitrage is the second, I think, most competitive piece. And like, so unlike many searcher teams, we're not doing the so-called long tail arbitrage, but we are just focusing on this one particular strategy, which is backrunning user order flow and doing an arbitrage in the same block.
So yeah, my second question was actually really about this MEV current landscape, right? So right now, like if anybody who is, who is now interested in MEV, he's just entered into this space, right? So what will be a good advice from your side in terms of becoming a searcher, or maybe they should become a builder, or they should, become both, or like what will be your advice? These days I've seen specifically searchers focus on, particular apps like, recently there was friend attacks. I've seen the static stats of MEV there. So what's your advice? Go ahead.
So what I think actually, and that if you are a solo searcher and you do not have lots of resources to start with, and you don't have any capital, you don't have any relevant experience from the past, I think it would be easier to do this long tail arbitrage, focusing on not very competitive chains or not very the new apps. So basically, you are betting that these apps will become popular enough, so you'll start making a revenue before everyone else. Because large searchers like us, we are focusing on apps that are already popular, and so there's always a room for small searchers to hop on this train before it gets some traction. So as with friend attack, the first bots appeared, I think, even like in the first 20 hours, of when it came live, because it used very simple APIs. Because I too checked this. I wanted to make a bot, a simple bot for friend attack, and it is very simple APIs. It was very simple to actually create a bot in like literally hours, and so users who like registered and so who made their bots fast, they profited a lot when it became really popular, because friend attacks became, like, I think, much more popular and everyone have been expecting it to be, those who hoped early, they've like earned pretty much a lot of revenue. And if you're a sole searcher, you should target apps like that. You should target chains like that. So and it would not be like a good volume, or it will not be a good revenue unless the app will become popular. But it's a good start. So and I think it's the only viable option for someone to get an experience for like the actual searching experience, because there's a lot of like places where you can get make mistakes, and there's a lot of like it's very complex. Like usually MEV, it's because it requires you to be very knowledgeable in execution clients, in how consensus on particular chain works. So, for example, searching on Ethereum and searching on BSC is two very different beasts, because the consensus on BSC is wildly different than the one from Ethereum. Yeah, because if you send transaction on BSC, you would not be included in the next block, but in 2 blocks after the current block. Yeah, and so previously you had to predict. And you still have to predict what the next block will be, and because you're actually targeted not this block but the block after it. Like that's a very like a complex topic, and there's a lot of other chains. For example, the Avalanche that has it actually has a private mempool that actually is not available for normal people running clients. You have to be the validator to have access to the mempool. And so every chain has a lot of nuances, And if you're a searcher, if you're starting as a searcher, it's both. It is. I think it's mostly positive thing for you, because it actually gatekeeps other teams, large teams that are already competing on large chains to enter. So they're not entering other chains because of these nuances, and these nuances will also help you to get hands-on experience of participating in like this market. So yeah, I think you should target these long tail opportunities if you're starting. So that's my like general advice. But otherwise, if you want to have sandwiches or arbitrage, that's the most like because these are the most popular topics. Everyone's talking about sandwiches. Everyone says, look, these bots are making like millions in profits. Like look at the Jared from Subway, etc., etc. So and everyone wants to be the next Jared, right? So they do not want to like have to make a ramen profitable bots, right? To make like hundreds of dollars per month. They want to make millions right away, and that's the common mistake like people are making, because these are highly competitive like niches. And they are not a great like place to start. Yeah.
So I've actually heard somewhere that like 50 to 60% of the job is to reduce latency, and the rest is code optimization. Like, is that true?
It depends on the chain again. So yeah, on Binance Smart Chain on BSC, for example, where we also operate, so the latency, I think, is one of the greatest things that you're optimizing for. It's not that crucial since Blockstrought came with their own block auction. But before, when everyone were operating in transaction pool, the latency was very, very, very important, and especially because that Binance had a lot of pools. They had much more tokens than there's on Ethereum. So I think now it has literally like millions of pairs deployed. Like that's a huge number, because on Ethereum you cannot imagine that much of the Uniswap pools being deployed, but on like Binance Smart Chain, where all the fees are negligible, you can like easily deploy. And so all the like shitcoin makers, creators, devs, they are spamming these pairs like crazy. And so there's like 10, I think maybe tens of thousands of new pools created each day on Binance Smart Chain. And so there's a lot of room for optimization, because you have to make a bot that would actually be able to process all these pairs. And and so the latency, so because the block is only 3 seconds on Binance Smart Chain, you have to be able to process like hundreds of millions of like arbitrage cycles in just a matter of like milliseconds, to be able to place your own transaction there before everyone else. So that's a huge factor in such chains. But on Ethereum, I think it's not that crucial, especially if you're starting, if you're like middle like searcher, the average searcher, and so the latency is not the first thing you're targeting for. So your first target, if you're starting, is to actually have proof of concept that works, because there's a lot of points of failure there, and you have to you can make mistake literally everywhere. So you can make mistakes in the contracts that makes your solution revert on chain. You can like make wrong bundles that would revert. You can make wrong computations, wrong optimizations on off chain. I mean optimizations that are optimizing for parameters that you would pass in the smart contract, such as amount in, if you are doing arbitrage, for example. So amount of tokens you're actually be swapping in this arbitrary cycle. So so what you're targeting on the view is to make just the bot that works, and that works in a matter of 12 seconds. So that's already hard. Believe that. It's not that easy, because our first bot, I think, our first proof of concept that we made, I think, it's made all its computations, I think, for way longer time than 30 seconds. So we computed all our arbitrage rides after 2 blocks or 3 blocks already came out. And because it's actually from the mathematical optimization standpoint and point of view, this is a very hard mathematical problem to optimize. And so, yeah, and so just having a bot that would somehow work, it's already great. And so latency, I think, is not really important unless you are working on very latency optimized chain, because I think maybe on chains like Solana it will be a great deal, because they're actually it's actually a high performance chain. On things like Arbitrum, for example, or Optimism, where you have to ping. I don't know about Optimism, but I remember that on Arbitrum you have to ping constantly their sequencer. So they will send you the latest state update about the Arbitrum state, so you can have the latest price on all the pools you're interested in. So the latency there was a huge deal, and because the Arbitrum doesn't actually have any blocks, right? They're processing all these transactions in first in, first out order.
Actually, that is very interesting. I wanted to get into this L2 topic. So what is going to happen in these L2s? Because PBS eventually, the proposer builder separation is eventually not going to come on these L2s, right? So with having a centralized sequencer, I think it's taking a step back. So what's your views on that?
That's very interesting topic, and as you know, there's a huge narrative in Ethereum space that there's at some point there will be a shared sequencer, and so many teams, I think, maybe not a lot of teams, but the ones that are doing it are very vocal, I guess, and a lot of people are talking about it, is that we're we right now we have centralized sequencer, but we will make a better one. So we're now focused on stuff that just works, but in the near future we'll work on that and we'll make a decentralized sequencer. Of course, I think that centralized sequencer is a step back in terms of actually the crypto values, right, that I have in the industry, and the first of all this is decentralization, actually, and Arbitrum makes it all. Not Arbitrum, but most of L2s introduces a lot of compromises that makes these values non-existent, and so they're very centralized. In terms of PBS and all these auctions, I think that it's very we have to come a long way before it gets there. I don't think that PBS, the Flashbots themselves, are very targeted towards launching their systems on L2, because it's too far. It's too far before that point, so we can think about that. And so I think who will first launch on such L2s would be order flow auctions. For example, I already mentioned the wall chain. They are integrating right into the DApps, and so they're basically chain agnostic, and their system does not really depend on the settlement layer and on the execution layer, and so because they're integrating their system into DApp, then user sends their intent to swap a transaction. They're connecting user to the searcher, and then searcher sends some kind of quote of how much MEV rebate they will give to the user back for their trade. So basically, there's searchers who are bidding for user trades, and then when user actually makes a transaction, it goes to the searcher first. Then searcher executes its arbitrage. It goes to the searcher in an unsigned way. So the searcher actually doesn't have a raw transaction, so it can't execute it for the user. The user will have to execute the transaction himself. So the searcher makes his own solution. It sends it to the wall chain auction, and the wall chain chooses the best solution among all the searchers that who bid on this user trade, and then they send the solution back to the user, and it's the user who sends the full transaction on chain. So it includes cold data, the wall chain dives to the user, and so this kind of auction, as I said, it's chain agnostic. It's there. I think they're already launched in the Arbitrum. They launched on Binance Smart Chain, and I think they're live on like 7 chains already or something. And so they're looking for the apps to integrate with, because that's the hardest part. So you have to onboard actual DApp developers, so they can integrate the Wallchain's SDK into their UI. And that's very hard. Would be very hard for to integrate with the giants like Uniswap, right? Because Uniswap is like positions itself as like very neutral enter, and so they're trying to make all their systems in-house without involving everyone from the side. So it would be very hard for these order flow auctions to integrate with the DD apps, but technically I think that's the only possible way to be live on L2s. So there's no other way such any kind of auctions would be able to integrate, would be able to go live on these L2s. Yeah.
Okay, got it. Okay, yeah. So now my next question would be like around enshrined PBS. So like currently, how is your relationship? Like how is one's relationship is like searcher and builder relationship right now? So searchers creates his bundle. Does he broadcast his bundles to all the block builders? Like how is that relationship? And then also like right now, I have heard that there is in the MEV Boost, with MEV Boost, there is problem with centralized relayers, right? So how is that gonna change with enshrined PBS?
So I think that there is a huge room for improvement in the PBS design, and I think that Flashbots, like, they are doing a great job there. So they're like, and so currently, how does it work? So the searcher create their bundles. They are choosing builders to send it to. So they are not mandated to send their bundles to all builders that they can choose, they can pick, because being a builder is permissionless right now, right? And being a relay is permissionless too. So you can be an actor in all of these stages of pipeline. And so what that means is that we have every builder and every relay have no guarantees that they're actually not acting against searchers or against users, right? So you can become a builder, and for example, as we saw, you can unbundle blocks. Unbundle the bundles. That's a huge deal for sandwichers. Because their main risk is the actual unbundling, because they will hold an inventory in a token that's usually a very illiquid token, and they would not like to have such kind of exposure. So they would like to have their bundle being atomic, and so builders does not have any guarantees that they're not acting against searchers. relays have no guarantee fix. So there's so all this pipeline is like based on trust, and it's not a really provable trust, but the only proof of trust is history. So because it's a blockchain, we see who landed which block, we see the history, which bundles were being sent to the builder, how builder has acted, what it sent to the relay, etc. So most of this data is public, and so if someone is acting against someone else, so we'll see that, and that's the only reason why this pipeline works somehow, because the only thing that makes searchers and builders and relays to be trusted is the history. So and then builders would build blocks with bundles that searchers have sent them, and then the blocks that they have built, they send it to relays. Relays are choosing the best block possible and send it to validators. And so I think the huge issue there that is widely discussed is that that relays don't actually have a revenue model. So the relays are considered currently as a public good, and so to run a relay, it's very costly in operation-wise. So it's like hundreds of thousands of dollars per year to just run a relay, and so it's a huge issue because this is I think it's I think it's maybe the most important actor, because it's actually who decides which blocks should be included on chain, which blocks it propagates to all the validators, because validators do not decide on anything; they're just receiving blocks, and the validator is one who gives it, who makes a decision, and so it actually makes a huge so it's an issue because there is a possibility that in the future, or there's like technical possibility and theoretical possibility that the relay can be bribed by builders. So this relay could choose the block that's not the best block in terms of revenue to validators, but it can choose the block that's best for revenue of the relay. So builders can include bribes not only to validators, as it currently happens, but they can also include bribe for the relay itself. So it would be actually a very sustainable model for relays, because now relays will be receiving also a part of this, distribution of MEV, because currently they receive nothing. They just exist and they're operating at huge losses. And so the way that we can front run this issue, as Flashbots did with the original MEV problem, we can also introduce some kind of reward model to relays as well. So instead of them getting bribes undisclosed in an undisclosed way, that might happen. So it would be very easy to hide, for example, right? So the relay might get bribed, and it may change addresses, for example, very frequently, and we will not see that it's actually getting bribed, and it's acting against the whole system. But so we can actually make a legit reward model that would require sharing, that would make builders share a part of their revenue with relays as well, in a legit, transparent way. So that's, I think, the problem that people are discussing, and because that's one of the one of the greatest issues, I think, with the current PBS auction design. Yeah, so there's actually like other direction to think about it, because there's not a lot of builders currently, right? So there's like 4 major builders or something like that that are building blocks. It actually may happen that having the relays is not it's not a requirement for this system to be live, right? So what builders can do is that they can integrate with relays, so they can run their own relays. For example, like Builder 69 or like rsync or the Beaver build, like major builders can create their own relays, right? And so there was a lot of talks that the builders are integrated with searchers. So this is called searcher integrated builder, right? So there's vertical integration between searchers and builders. But now we can talk about like integration between builders and relays. So builder can integrate the relay into that, like their whole pipeline. And so that's actually, that would be, I think, a threat to decentralization. Because because currently all the relays that are running are pretty neutral. They're neutral, that receive bundles from all builders that exist. But if major builders will run their own relays, and because they're already dominating the market, they will reach the same amounts or the same number of validators that current neutral relays have. And so they will be just keep dominating and actual neutral relays will die because they're operating at loss. But because builders will run their own relays, they will be like, it will be profitable for them to run these relays. Then validators will not care from who they will receive their blocks, from neutral builders or from neutral relays like now, or from biased integrated relays integrated into builders. So they will not care from who they will receive these blocks. And yeah, and so because neutral relays will die, there will be no room for future builders to come, because they will not only have to run their own builder, but they also will have to have a relay that will have to acquire all the validators on Ethereum, and that's like impossible. So and we'll be stuck with all these like 4 builders.
Yeah.
And so yeah, that's a huge like incentive issue that we have currently. And so currently for our own goods, it's purely theoretical. But things in MEV landscape moves really fast, I think.
Yeah.
And so because especially at the bull market, when the MEV is like it is becoming huge in volume.
Yeah.
All these incentives are like being accelerated and leveraged, and now like it may become like from theoretical issue to like a real issue, and no one will be able to stop the builders who are dominating the market currently from integrating it, because like that's a permissionless system. Everyone can do whatever he wants, and so yeah.
Yeah, that's quite amazing. I've seen a lot of memes on Twitter as well, that relays asking searchers and be like, "Hey, are you guys getting paid?"
Yeah, I remember that. It was really
Yeah, so that's really helpful. Okay, yeah, so yeah, I guess that was really insightful, and thanks for that. Okay, and also by discussing this, there is a lot of opportunities in the research space as well, as he mentioned that a lot of opportunities are there in this space. So if you are a researcher or someone, go into this space, learn about MEV, learn about these 3 layers. If you're a researcher, just, give your advices how we can, improve this space and how you can, create decentralization and make sure that decentralization is there. Okay. Yeah. Moving on to last question. What are you bullish on in 2024, especially in terms of MEV? Right. I mean, SUAVE is coming from Flashbots. There was also EigenLayer, PEPC, right? So especially in the MEV space, what are you bullish on in 2024?
Yeah, so SUAVE is a very discussed topic because everything that Flashbots did were quite adopted very warmly in the space. So everyone not liked what they did. For example, I started my Twitter journey with the threads that criticized Flashbots and their auction design, and because I didn't really like what they have done. Yeah.
First you criticize them and then you join them.
Yeah. But then no one had a choice but to adopt this system because they have become favorable by validators, and the validators they are the ones who are settling all the blocks, and so initially it was miners. So we searchers are very poor people in terms that no one listens to us. I mean, I mean, we are not crucial part of the system, so we are replaceable. All the searches. So one searcher goes away, the others will come, because that's why we are bidding 90% of all our profits. So we are left with a very little profits because we are at the very start of this supply chain, and so we are not the ones who are making decisions, right? So the builders will make their decisions, the relays will make their decisions, and then the validators who will make their decisions as well. But searchers, they're not making any decision. So yeah, everything that Flashbots did was adopted very well, and so they're working on SUAVE now. They're very focused on it, and so a lot of people are bullish on SUAVE because it's unionizes all the auction between all the chains as they're staking. I don't think that it will be as adopted as the current PBS design, to be honest. So I'm not really. I would not say I'm bullish on SUAVE, to be honest, because current system, the current PBS design, while it's flawed, it's it's very it's a trusted pipeline. But we can improve that, as I mentioned. And it's an old working system. It's relatively transparent, and it's technically it's an easy system because it doesn't have any strong guarantees. It's an easy to implement, and so it's easy to participate in currently. And so, for example, our team is making Builder right now, and we will working on Builder for since PBS came out. We just didn't have enough order flow, a private order flow to start and be competitive. But it's an easy system. But SUAVE, I think it's a different beast in terms of complexity. Mm-hmm. And it will be much more complex to actually implement and run, I think. And so much less people would understand all of the nuances of SUAVE. And so the Flashbots will dominate the space again. And it would be very hard to actually decentralize, not in terms of in theoretical terms, but it's just only Flashbots team who will understand how SUAVE actually works. And so no one will be able to just easily build for all of this ecosystem, because the PBS ecosystem is very diverse. There's a lot of factors on all of these levels. But SUAVE tries to unionize it and make it all into one integrated system, that will just work for everyone. But no one will actually be incentivized to implement it in the first place because they already have PBS. So SUAVE doesn't give any more revenue to validators. It doesn't give any more revenue to builders. It doesn't give any more revenue to almost everyone. So it makes the same job, but with more guarantees. But I'm not sure that these guarantees are demanded by all people that are actually in the MEV space. So I'm not saying I'm bullish on SUAVE. So what I'm bullish on, as I mentioned, is order flow auctions. So this so the one problem is that the huge part of the supply chain is currently mostly untouched. That's the interaction of users, wallets, and other order flow originators with searchers and builders. Because currently most of the order flow are still coming from public transaction pool, and but you know that there's already the most popular order flow auction called MEV Blocker, right? That takes orders from users, and it actually bypasses all the mempool operations and gives these transactions directly to builders privately. And so I think that's the last part of the supply chain that's relatively untouched, and the competition will shift from competing among searchers and builders. It will shift to competing for users, for user acquisitions directly. So each party we would like to have the exclusive order flow to not compete with others in the public space. So they would like to acquire users directly from the apps, or acquire users from for example, Telegram bots, trading Telegram bots, and like many order flow. There's many order flow originators that would be everyone would like to acquire and get the order flow from them. So that's what I'm bullish in 2024. So I don't think that's like a huge topic for newcomers because of that's like. But in terms of the overall design and overall like ecosystem, I think that's an actual end game. And developments of these order flow auctions that would not be on auctions for the block space, but be the auctions for the actual users. I think that would be the major topic in the MEV space in 2024. And I think that's a single the single topic that would be actually relevant, because the current competition, the only thing that really matters, it's not the latencies, it's not anything else, because it's an already explored. Because we usually say about like MEV that it's a dark forest, right? But and the Flashbots came to like to give us a lesson that would like give you to light this dark forest. But I think actually this dark forest is mostly explored already, like by the top teams especially, and there's almost no alpha left in the space. And so everyone are trying to shift the competition to unexplored areas, and the single unexplored area is the actual interaction with the user. So yeah, that's what I'm most bullish on 2024.
That's actually awesome. Yeah, awesome. Yeah, I guess that was really insightful. So thank you so much for joining. Like, this means a lot. And yeah, maybe hopefully we will have another podcast where you can share more experiences, and maybe in 2025 you can come in again, share your experience in 2024 whether your things you're bullish on was successful or not. But yeah, thank you so much for joining. And yeah, I will drop the link to your Twitter, so if anybody wants to follow, go and just follow him on Twitter.
Yeah, really like to chat. Thanks for inviting me. See ya.